TigerBeetle sessions, Thursday, 27th of January, session 12. Hey, Joran, what's up?
Hey, Isaac, what's up? Nice to be back.
Um,
Okay, should I run us by yesterday? What
Go
were we
for
up
it.
to? Yeah, cool. Um, I always think of that ad, what's up? I couldn't resist. Yeah, so yeah, yesterday was pretty fun. We were working on the node pool to do static allocation, give us a whole lot of like 64 kilobyte nodes or something like that. Basically, each node we can acquire from that pool and start constructing these segmented arrays. We've got sort of like a linked list, but each node contains many elements, which gives you something called an unrolled linked list, or we're calling it a segmented array because it's basically like a big fixed size array, just cut up into a few smaller segments, so you get very nice insert performance and it's benefits of linked list and an array. So today we've got the segment array built, we've got the node pool built that it's going to use, and we want to now fuzz test it uh, and see how far we get with the fuzz test. Maybe go a bit further, and yeah, in how we're actually using the segmented array. Uh, have I covered everything? Uh,
I think so. I'll share my screen. We can get started.
yeah, let's go.
All right. Cool. Segmented array. All right. So yeah, towards the end, we just kind of copy pasted our test case for node pool in here, and then started modifying it to fit the segmented array requirements. But we didn't get very far with that yet.
Yeah.
Um, one thing we did change is we made segmented array generic over the node pool instead of over the node size. And node size we just kind of take from the node pool's type. Um, yeah, this is all looking good. Cool. So I think
That
our next step is
that
just to keep on.
yeah, that div exact comment is so nice to see each time,
Oh yeah, it definitely is good just for the longevity of this code base that we intend.
Yeah.
Um, I mean, we're gonna come back here in like 5 years and be like, yeah, okay, that makes sense. Thank you for
Yeah.
leaving a comment past us.
Yeah. You know what? Maybe
Um,
we should just add to that and say this means that there may be extra padding at the end of the node.
sure.
Maybe padding at the end of the node.
Can wrap this. All right, let's do that.
Yeah.
Test context. Um, got a node count, random test pool. We also need a test array. Um, we can just call it array maybe.
Yeah.
Test array. And then we also need like to verify it against. I think we can just use an array list probably, because we won't make it too terribly large, I don't think, for the tests.
Yeah.
And then the array list, we can just allocate all just like insert ensure capacity up front, and then do inserts and removes.
Up
That should
up
work
to
fine, I think.
up to a certain amount. Yeah.
Yeah. What do we want to call that though? That's like well, we can have like kind of two things here, like, um,
It's a reference.
well,
It's like
yeah, I
a
guess reference.
reference implementation. So just reference is great.
I think just reference and make that see that. List T, I guess. And I think that's it. there. We can just kind of stick the allocator in there. I'm always
Yeah,
for making tests like slightly inefficient in terms of memory usage to make them just simpler to write and more
yeah,
ergonomic to work with.
yep,
We don't need to go all the way there.
no,
So yeah,
yeah, that definitely makes sense. It just makes the test code, yeah, we're not passing in the allocator all the time.
yeah. Though we can actually for this, I realized that we can allocate everything up front and just use like ensure or assume capacity.
Yeah,
So we don't really need the allocator up front, but
no,
doesn't hurt, I guess.
no, yeah,
So I guess I'll just start initializing stuff then.
yeah,
Um, Node count, is that still part of our? I think it isn't. That's now part of
yeah. Part of
the
segmented array is going to work that out, I think.
node. Oh, it is there. Okay, that makes sense. It's here, node count max.
Yeah,
Um, and we actually already had that here. Neat. So this is now. Um, we need to store this. Is the question more? I think we already have it as this type, so we don't need to store it.
yeah,
I think we already have like this comp time known value here in this context, so we don't need to store it in the struct.
yeah.
Um, okay, next thing up is the test array itself, I believe. Equals. Yeah, let's return self as an allocator. Or what does it take? Just an allocator. Nice. Doesn't take a node pool? Oh, we just passed in the node pool when we need it. That's right. Okay.
Yeah, it's the
Cool.
unmanaged version.
Yep. All right. Here we've got node pool and we've got array.
Oh, when we de-init it, we do provide the node pool because the de-init
Right.
will return everything back into the node pool. And if the node pool comes after the allocator,
It does.
yeah. I've been thinking for Tiger style, we can also add this in there, the arguments that have the longest lifeline or that are the heaviest, lifetime or are the heaviest, they sort of come first. So the allocator is something like very, very global to the whole program and
Yeah.
then on and on. Node pool is
That's a
sort
good
of
rule.
based off the allocator and so on.
I feel like we've kind of like just been intuitively doing that, so it probably makes sense to codify it.
Exactly,
Um,
yeah. Yeah. I saw the standard lib did that too. There was something where it's got switched around in one place. The allocator was
yeah,
bumped forward. Yeah.
cool. Um, array we've got in here now too. Sentinel's gone. Next up is we've got here kind of now we kind of want to match the order here. I think random's kind of like part of the test, and then these are like the things being tested.
Yeah.
We got reference and we've got some data. Where's the references next? Here, te.init testing.allocator. And we can do like reference.ensure capacity, node count, or element count max.
Yeah. Is element count max, do we have that in this comp time scope?
Yeah, it's comp
We
time
do.
known.
Okay,
Oops.
great. Isaac, I was thinking, you know how we've got node pool and array on line 23 upstairs? Uh,
Yep.
the types are called a little bit further up in the fields. Yeah, the types are test pool and test array. So maybe we could do pool and array.
Just
Uh,
here.
yeah, or we could do nodes and array. Then it lines up. Nodes acquire, and then you get a node.
Sure.
I don't know if you like that. Uh, or if you want to
Yeah,
do, maybe pool is better.
we call it node pool like everywhere throughout this code, which I
Yeah,
do kind of like.
yeah,
Yeah, we always call it node pool up there, and there are quite a few. I think it makes sense to do it like that up there, right?
yeah.
Um,
Okay, cool. Then we'd leave it like that. You
I think I'll
mean
just leave it.
you mean you want to leave it there, but here just call it pool.
Um, I don't really mind what we call it here. I think it makes sense to leave it as node pool up here,
Yeah,
but I don't
yeah,
know. Here it doesn't really matter to me as much, so I was inclined to just leave it the same.
yeah.
I think node pool is just like the right name for it. It's a
Okay,
node pool.
yeah,
If you just call it pool, it's not really clear what it's a pool of.
yeah,
Um, and just nodes, it seems kind of weird. It's like it could be a list of nodes, or it could be
yeah.
many different things.
Okay, cool.
Reference. So that's all the things we've got here for now. So that's everything initialized. I guess we can just do the DNet now too. Node math.
Uh, yeah, sorry to come back on it. I thought maybe then we can call the type like test node pool instead of test pool.
Sure, that makes sense. Um, seems still fine. Good.
Yeah,
Read at DNet. That's gonna be the other order, I think. Yeah. I mean, the order here is not important because we need to do the node this DNet first before we DNet the node pool.
yeah,
'Cause this one uses the node pool.
okay.
Um, the
That
reference array can just be DNet whatever order though.
yeah, that was a really nice decision, for that dinit interface to make it explicit that it takes the node pool so you
Yeah.
can see that the order matters. Yeah, yeah,
Yeah. Reference DNet. That's it. I guess we maybe leave a new line in here since those two are related and this one isn't.
yeah,
Yeah. So there we've got net DNet done. Now next up, I guess, well, run probably needs to be reworked entirely, but we should probably do like the lower level insert,
yeah.
remove routines first.
I
I
think
don't know.
in it we should just do one thing for hygiene. Just add an error defer to. Oh, we do have it already to de-init the reference. Okay, sorry.
Mm-hmm.
Uh, yeah, I saw that last try and show capacity. Uh,
Cool.
yeah, good.
So the fuzz testing strategy, we wanted to just kind of keep the reference and the actual array, segmented array parallel at all times. Um, and so insert the same, I guess, random element to them. Um, so
Yeah,
I guess we're just gonna have a function that generates a random element and inserts it to a random location too.
yeah,
Um,
random location, and we're going to be calling the bulk API, so insert elements, remove elements, and
cool.
each time we mutate, so we'll either insert or we'll remove. Each time we mutate, after the mutate, we want to compare across the whole array that it's exactly the same logically.
Yeah. So um,
And I'm thinking
we have like,
what'll also be good is if we sometimes after we do an insert, we immediately do another insert before or after in the same area. Uh,
Okay, yeah.
might be.
So what abstractions do we want here then? Just like a simple insert method to start with, perhaps?
Yeah, yeah. We can rename acquire and release to insert and remove.
And remove. Do they just choose their own random place to do this, or should they like take a parameter?
They do everything themselves.
Okay, should we maybe I don't do we even want release all? I'll just delete it for now. We might not need it.
I think we do at the end we'll say remove all, and then we will check that the whole thing is then empty.
Sure.
Yeah, that'll be like a special remove where you're removing a slice that's actually the whole array. Yeah.
Sounds good.
Yeah.
Um, yeah. We insert. I guess we're gonna first thing is just generate a random thing to insert. The const. Oh, we want to insert like a slice though, so we need multiple of these.
Yeah.
So here's the first thing to just determine the length randomly. Like maybe like 1 to 5 items. I don't know.
Yeah.
What kind of node size do we want here? You
We
know,
want.
if we allow inserting more items at once than fit in a node, like if we allow inserting like node size um plus 2 items, then it can potentially like lie across 3 separate nodes.
Yeah.
And that would make our two methods that we want to make optimal even more complex. We might want to limit that to like the items per node, like how much you can insert at once. I'm not sure.
Yeah. I was thinking that we could exploit that for our bulk insert. That like if someone is inserting more than a node, it'll make the bulk pretty cheap because we're literally just putting in. I don't know if we should, but I understand that it can make it complex, but I don't think we should limit the interface for that because we don't really know
Okay.
the interaction between our max number of tables, you know? Well,
Yeah, I think it doesn't make the interface cheap. It makes it still just as expensive as otherwise. It just gets more complex. Because then you've got to like kind of split a node in half, and then add in. I think that special casing that would make things more complex than less
okay.
complex.
Yeah.
Um,
Yeah. Well, we could say so we do actually know the max size of a remove or insert because
yeah,
it's um, what it would do is it would push back on our config, so our LSM growth factor would then be limited. You wouldn't be able to do growth factors more than something because that'll then run up against it'll start to interact with your segmented array node sizes. Yeah.
yeah, okay, that makes sense. Um, yeah, I mean, maybe it isn't that bad to just handle, but I think it. I think we'll find that it's pretty complex when we get to that
Yeah.
to handle arbitrary large inserts. Um,
I
so
I
if
thought
it's less than
uh,
yeah.
yeah, to me it felt it maybe it's complex, but it maybe it will be, we'll see. But my feeling was, I mean, I'm just placing a bet just to say, and then we can see when it comes to it. But
Sure, yeah.
I was thinking intuitively to me, like if the I like the batch idea because if we can make it work, then I think of it as like we've got some stuff to put in, and we see how much of the stuff fits into its own node, and we just insert that, and then we just keep going until we have to actually put into an existing node, and then it just becomes a normal insert. And that's how we get the nice bulk
Uh,
perform the
the
bulk.
tricky part though is that putting it into its own node isn't sufficient though, because it's not going to end up that your stuff starts being inserted exactly in the space between two nodes. So you've got to always insert a new node, but then also shift stuff from the previous node after the stuff you're inserting,
Yeah,
and then find space for that stuff as well. And that's the part
yeah,
that gets tricky, I think.
yeah, yeah.
Um,
We could do that now that we're talking about it. Like what we could do is simplify the space so that we say if we're doing a bulk insert, we straight away split. We always just split. We don't even think about it, so that we in our own area. We put it in as a node and then we just join it up on the sides and compact.
it sounds like it's going to introduce unnecessary copies, and
Yeah, yeah,
maybe it's still faster than what we have right now. It probably would be, but I think it's not maximally efficient.
yeah,
Um,
yeah. No, I agree. Just a simple thing, to as a way to make it easy to reason about. But it doesn't matter. Maybe we can, like our node is, so we're thinking that like a node is going to be more than 4 kilobytes. So that's a lot of table infos. So we're not really going to push against this relation between Allison growth factor and
Yeah, that's what I was kind of intuitively thinking. I think we are solving a problem we don't actually have by
yeah,
making both insert title more than a node worth of elements.
yeah,
Um,
yeah. Okay, cool. Then we can enforce that in the API, like that there's a restriction, and then
yeah, I think
test it like that too.
oops. Cool, so that'd be, insert elements. So here, what's the right way to do this? We can say, there's not really a type for like a maximum length n.
Yeah,
Best way you can do that, best you can do in the type system is like say like a pointer to array of size n and then also a separate length, but then that's more error prone, I think.
yeah,
I think instead we should just assert that the length is less than the elements per node.
yeah. Thinking the same.
Um,
That's a good idea, Isaac. Like to just tighten it up and promise less.
thank you.
Yeah,
This is node capacity. Node
yeah,
capacity should also be public then, so that the
yeah,
caller can like inspect it if they want.
mm,
Um, I guess.
yeah. And um, our assert there, we should actually do less than equal to.
Indeed. Whoops.
I've been realizing because I get to watch, which is quite nice, But I've been realizing every time I think whenever we do a condition, in the past I used to think like off by one was always to do with arithmetic, but I've realized that actually
It's
it's
always those
just
conditional things.
it's these conditionals, yeah. So now what
Yeah.
I do while we're pair programming, whenever we write any conditional, I always ask, is there an off by one? Because
Yeah, I think I've
it's
also
so
started to
easy.
lean on you a bit for these things. Because
Sorry,
I
sorry.
like don't bother. I think I've started to lean on your watchful eyes for these things too. I don't bother
Yeah,
thinking
yeah,
about them as much because I
yeah.
know you'll correct me when I get it wrong.
Okay, yeah. I didn't have much sleep last night, so you should just be careful today, because I might not be.
I probably should think about them myself too. That'd be more safe.
Yeah,
Um,
yeah,
Move elements. So here we just kind of start on count. Whoops. Um, um, Not that. It's node capacity. There we go.
were you just
And these
testing
ones should.
testing me there? Because I missed that one.
Cool. So now we've got those as part of the API. Nice. That makes me more confident in our ability to implement bulk insert efficiently and
Yeah,
simply.
yeah,
Um,
nice.
uh, knit.
Oh, you know what? Maybe we can add a to do at that assert, and in our comp time, like config stuff, we need to add a comp time assert to check the relations, between growth factor and this runtime assert.
So compiler is definitely better than a runtime error if you run
Yeah,
into this.
yeah,
I think just one to do on the first one's fine.
yeah.
The remove, it's like the same to do.
So yeah,
Okay, cool. So now we've got a way to, now we can test that API right here. So our maximum slice length is going to be, we can kind of just like choose totally random bytes, right, for this slice. Um, we can just have a buffer.
yeah.
We can have here essentially our bar buffer is going to be, well, we actually want this to be the buffer of t's. So this will mean node capacity. Um, test array node capacity t equals undefined to start with. Then we're going to fill in with random bytes. Buffer, or, well, we need to choose a length first.
I,
Um,
I think what we should do is just use a 64-bit or 128-bit integer. Then we don't have to. Then it makes it simpler to compare things. We don't have to do slices of bytes.
um, don't we want to insert up to node capacity items maximum though in a single insert? Will we test that?
Oh, sorry. What I was referring to is T. Our T here can be like a U128.
Well, we can set t to that, yeah.
Yeah,
T is like the type stored in test array, and so
yeah, yeah.
we can choose in the outer test thing that we always use like 64 or 32 or whatever t. We
Okay.
can require tree to be primitive. Um,
Okay, but I guess yeah, the underlying data for T, we can't really think about T as a U128 here because it's comp time known. So we're just gonna give it raw
yeah,
random memory behind there.
yeah.
Okay, good,
Um,
good.
yeah. Well, we can like assert that t is like a U32 or U64 or something for our test purposes. We also want to test like structs for t. Um,
Yeah, I think scratch my idea about a U1. I thought it might make it easier to generate random data. Just get a random int of U128. But I don't
well,
think we
this is
should.
actually gonna be even easier than that.
Ex,
For
ex,
if we're
yeah,
just gonna do random bytes on the buffer.
yeah, yeah.
Um,
Cool. No, scratch that one. Yeah.
cool. Um, what are we on now? We've got, well, we've got to choose our length now. So const um, count equals or context random that uint less than biased, or at most biased actually.
Yeah. I think it's int at most.
Yeah, uint at, really?
Uint.
Hold
Yeah.
on. At most
Uint.
biased. Here we
Yeah.
go. And this is
Sorry,
going
I'll
to be type.
be back in a second.
Go ahead.
Okay.
This must be a U size maybe, or just go with U32 will be work out fine. And our maximum here is then going to be node capacity, of course. So that goes the count we want to insert. Um, then we're going to take buffer. Um, slice it up to this count. Then we're gonna call mem.as bytes on it. And then we're gonna pass this to random or context.random.bytes. That's going to fill our buffer with random bytes now, up to count. Then we can just insert the slice into our array. So then we're going to do context.array.insert elements, which takes a node pool, context.node pool. What else did it take? A couple things. On. It's not going to tell me. On ZLS. Absolute index and elements. So the index we also need to choose randomly then.
Yeah.
So the index will be context.random.uint most biased. This is starting at, this can also be a U32. This is going to go up to
Elements count
the current.
We could choose the count first, and then use that to influence the index, or we could choose the index first.
Yeah, I think choosing the count first makes sense.
Okay.
So then we test the node capacity, the maximum count more often.
Okay.
Though actually we can then run into the case where we can't insert. Yeah, that works out, I think. Actually, so this is actually going to be a little slightly tricky then. So we actually think we want like a max index variable here first. Const max index. So this is going to use that max index. So this now needs to be like math.min test array or just element count max minus count. That's the upper bound. And then our other option is just the number of elements currently in our array. This is going to be, I guess, test array dot. We don't have a count method, do we here? Like to get the maximum absolute index. I guess we should just rely on the reference there though, probably. And just use reference.length. That makes sense.
We should also calculate this max index right up top of the function, because then we can use it to actually do an early return if the array is full.
Oh yeah, we probably should.
Yeah. And I think we should also express it not as max index, but as count or as remaining or free, because these calculations are all counts, not indices. To get to an index, we've got to do a minus 1. The unit.
Okay, yeah, you're right. I see. Yeah.
I've realized that, like recently too, is that index is like an index unit, and a count is a separate unit, like a quantity unit. So and there's always a way to convert between them. If you take something that's expressed in terms of a quantity, like a count, you just minus 1, then you get to the index. That's how you can go between the two. But because we expressing everything on the right-hand side as counts, then on the left we should call it like a count, and then we don't get it off by 1.
Yeah, definitely. And we do have an off by 1 here currently. Yeah. We'd have to use here like
less than
biased in order to use it like we have right now.
Yeah.
So what's this? I wanted actually a max index though. Maybe that's the wrong thing to call this.
We can get to it. We can maybe call it free. It's or remaining. It's how much space is left in the array.
But it's not exactly that. That would be context.reference.items.length, or that would be element count max minus this, which isn't exactly what we care about. Maybe that is what we care about though, because there's two parts here is the problem, because you also can't insert too close to the end if you have more than count. Is that true? No, you're right. This is I'm overcomplicating this again. You're right. We just needed to max inserts or yeah, space left
We
or
should call it,
free.
I think we should actually call it count free. So we say that like it is a count,
Free
and
count.
then and put count, like make free as the qualifier as the suffix. So you can see we're
And
dealing in
then this
terms
is
of,
just,
yeah,
that's all that is.
yeah,
That's the better way to write that.
yeah,
And then we say if count free 0, return.
yep,
And then we can also limit count then to the minimum of this and node capacity, I guess.
yeah. That's also important.
Count equals math min count free
And
test array node capacity. Actually, we can, you know what we can do here now is we can use minimum.
nice. And then let's call it count free max or count free min, so that we keep the suffix last. So, and I think count free min or max makes sense because we're taking count free and then further restricting it based on the node capacity.
Count free max seems weird to me somehow. I would rather just call this free and then call this max count. I don't know.
Okay, but then
We're only gonna use this in one place, like right here.
yeah, that's fine. Yeah. We should actually just put it in line. We don't need it any. We don't
Okay,
need it
that
again.
works too.
Yeah.
Um,
I was thinking more that we put max always as a suffix. The qualifier always goes at the end of the variable. That was just a tiny nit, not a
yeah,
big one.
right.
Yeah.
It's a little bit too long now, unfortunately, so I think I'm gonna put it back. And count maxes seems good to me.
Yeah. Yeah. That's cool because it's right. It's grouped right there with where we count let count.
Yep. An index. This is now maximum index is then gonna be count free. That doesn't seem right. So count free minus 1, right?
It'll be, yeah. Uh, and the easier way to do it is just to say uint less than biased and then let it go up to count. Up to
Well,
count.
actually, it's not count free though, isn't it? It's like the it would be like hmm. Yeah, it's not count free. Count free is like the space at the end that's free. We want the opposite of that though. Max index is just this. Um,
Yeah.
there's nothing else to it. It's just this.
That minus one, because that's length is the unit there is a count, not an index.
Yeah, so
But
it's gotta be less than.
yeah, then it's fine. Yeah. Cool.
Um, unit less than that. There we go. Still the random at in there. Okay. Now we've got our index and we've got our items. So now we can insert the items, elements, apps at index and then elements. Okay. So index and then or just buffer 0 dot count. And now I've got the insert done on the reference.
Yeah.
And then we're gonna have to do no, that's the actual thing. Then on the reference, we're also going to do the same thing. Well, does or at least have a broken insert method? Like,
I think okay.
insert slice. Yes, it does. Nice. What were you saying?
Yeah, I think we might have a little bug where if the array is totally empty, then reference items length will be 0, and we'll try and say, let's get an unsigned integer less than 0.
How does our insert elements handle an empty array? Do we allow?
So the bug isn't in our segmented array, but in
Yeah,
our,
yeah. So we actually don't need the -1 there. It should just be it should be just at most. Because we can't. It's valid to insert at items.length.
oh, it is, yeah, yeah, cool.
And I think the
Because,
array probably has the same thing. So context.reference dot
bec and that's because
insert
it's
slice.
because we know that items.length is less than the total length. So
Yeah.
that, yeah, cool.
Yeah. Copy backwards. What's going on here? So items is just repeated so many times. It's got items and
Yeah,
also self-set items. Um, yeah, this works the same way we ours does. Cool.
yeah.
Context. That's not right. Context. Okay, now we can go index buffer. And there, insert slice. There should be an assumed capacity variant of this, right? Is there
Yeah.
not? It's not an assumed capacity variant. It's too bad. I guess we need to catch and reachable then.
Yeah.
To do. Um,
What would be cool to do is where we calculate our index, just add a little assert directly above and say that context reference items.len is less than element count max.
sure.
Just so someone can see, like we did think about converting from the count to the index. Or it'll
Cool.
basically just be me that I will. It'll help me out, future me, you know. 'Cause that was
Cool with
what,
me.
yeah. I mean, I know we've already calculated it up top, so but yeah.
Cool. I think that works out pretty well then. We
Yeah.
insert a slice at a random index, and then do we want to do the verification here or outside this function or what?
Uh,
Actually, we
I
should
th
probably do it outside so we can reuse the same code and remove to verify. Um,
yeah, I think we should factor it out, but call it from within because we only need to verify if we've mutated it. If we haven't mutated it, then we don't need to
yeah,
verify. Yeah.
right, yeah. So I guess we have a verify function maybe down here.
Yeah. Yeah, that lines up.
Yeah. And then we're just gonna call it here and then try context of verify. All right, and here we're just gonna kind of loop over both of them and compare them, I guess. We need to get then an iterator for here. So which takes array absolute index start node and direction. And start node we can just pass in 0 to not skip over anything. Cool.
Yeah.
So our it equals context.array absolute index is 0, start node is 0, and ascending just to go in order, and then we're gonna just
Oh, wow. This is pretty cool. We can actually pass a direction to our verify as well, and sometimes decide to verify ascending or descending when we're checking our iterator as well.
you just do both.
Yeah, yeah, we can
Pretty
do
cool with
both.
that.
Yeah, both all the time.
Context.items or context.reference items, or what do we call this? This is like the expected.
Yeah, or just expect. Then we can use expect and actual.
Sure.
We did that in Eitzinger as well.
Yeah. Cool. Excuse me. And we have here, I think we want to do like as, so our or just like has this a t, right? This
Yeah,
next function. Yeah.
yeah,
Well, it's an optional pointer to t actually.
yeah,
We can make that work though. Um,
yeah. This is very nice. Like we're
so
gonna, I didn't realize we're actually testing our iterator as well. Yeah,
yeah, we test everything we
yeah,
have.
yeah,
It's pretty sweet.
yeah,
And this will be, this works, I think. And then we can just call it.next right here.
yeah,
And then we'll also check that it, and we can check at the end that it does that it returns null.
yeah.
Try testing that expect equal as const t null it. Oh, I forgot the dot here. So that's the ascending direction. I think that's quite clean actually.
Yeah,
Um, cool. And descending, we need to do a different loop here because we can't use for, sadly.
yeah,
Um, but that works out fine too.
yeah.
We'll just have to do, well, actually we should put this first in a block so we don't leak any variables. Then we'll have another block for descending. And we'll do the same thing from descending, and we need to then pass in the start index will be then the length, I guess. And this will be descending, and the start node, we don't actually know it, so we should just pass 0 here actually. Yeah. We should actually maybe pass in the last node in the
Yeah,
array,
just node count.
which will be node
Node
count
count
-1, I think.
-1 to turn it into an
It'll
index.
be, we have its last public. It
Yeah,
is. We can just use that.
okay. Even better than me testing
Uh,
that too.
yeah. I think we need to wrap this now. It's getting pretty long. That's not bad though.
Yeah,
Alright. Then we need to have an I for our reference. Equals context. And then we're going to subtract 1 in our inside our loop while I is greater than 0. We're going to do I -1 as the first in the loop. I 1, and then here we're going to do our try, copy this actually. Um, address.
Mm.
Or
Nice.
what did I just do? That's totally wrong. Hold up. Alright, there we go.
Very nice
Here I could just use the
reverse.
star to make it a bit cleaner.
A nice reverse
Hmm?
loop there. Nice reverse loop. Uh,
Thank
yeah,
you.
yeah.
I don't think there's any bounds or off by ones yet, so if there are, please tell
Yeah.
me. um,
Cool, cool. I'm checking.
we got the last thing here. I think that does it.
Hmm. Yeah, so we start at the last node. We descend. We, in both loops, we always use what's available in our reference. Um, okay, expect is pointed to the item.
Oh, you know what? We're not checking the right thing here. We're checking that the pointer addresses are the same. Um, we can't do that. We can check
Yeah,
that the items themselves are the same. Um,
yeah, yeah,
so yeah,
yeah,
what's the best way to do that then? I guess we just need to call it a next, and then if it's null, return like test failed, or expect it to not be equal to null, and then use the. Okay, so let's try this. Let's do um, expect. What's the? Is there like a reverse of expect? Expect error. Um, pub. FN. Okay, I guess we have to just. Oh, we can also just return the test error ourselves manually. That would work too.
yeah,
That's probably cleanest. Um, test unexpected result. Yeah, cool. So we're gonna say const actual equals it dot next, or else return error dot test unexpected result, and then we're gonna do here the normal by value comparison. Then
mm,
just say uh, expect, and then actual. Does that seem good?
yeah. That looks great. Then we still comparing two pointers, right?
No. Oh, well, as long as we get rid of this, then we aren't.
Yeah,
Um, now we're good. No, this one's still a pointer, you're right, so we need to dereference this one.
yeah.
Now we should be good.
Good. That's very clean.
And here we actually do want to use this. We just want to say that we get a null pointer as it's returned. So
Yeah,
that's all good there. Okay, and so here we can just kind of do that. We can want to do the same thing here exactly. Actual, and then this line's also the same. So now we just take the, yeah, copy expect, actual, and then expect equal those.
yeah.
Cool.
Uh, yeah, so those then are the same, those two lines, those last two, above and
Yep.
below, they're identical. Cool.
Yep.
And then the termination is the same.
Yep. Okay, the
Okay.
only difference should be the loops, and then
Yeah,
how we get access to expect.
yeah. What we could do here to test our test is we can keep a running count of how many things we've seen, and um, I don't know, our segmented array doesn't expose a count of how much stuff it's
No, it
got.
doesn't.
Yeah.
Because well, I guess it could.
Mm,
It actually has it privately, I think.
yeah.
Um, it's this last absolute index plus one
Okay.
would be the count. Um,
Cool.
Shall we
Because
just make a
then,
public method for that?
yeah,
Um,
we can expose it because that way we're checking all that machinery as well.
pub count array and we this is for just a specific node. So this is still different. This is different still. So U32,
Yeah.
and then we'll just here say return array dot indexes array dot node dot last dot node plus array dot counts now we need to extract the last node thing into a variable, I'd say.
I think what we should do there is just go through last absolute index and then pass the last node. Because that way we're also testing last absolute index.
Sure, that works too.
Yeah.
And we need to deal with the off by one though.
Then, yeah. Then we just add one back.
Last absolute index. That just needs to be those things. Friends. Then plus one. There we go.
Okay. If there's, I think we just wrong if there's nothing in the node at all. If it's zero, if
Yeah,
the,
yeah. I think you're right.
yeah.
Well, yeah. This doesn't handle this. Yeah. So if say so we need some branch for if array node count 0, then we're good.
Okay, it could still happen though because we allow empty nodes.
Do we really? I think we don't really.
Okay.
Um, we create one and insert,
Mm,
but then we immediately put something in it.
yeah. Maybe
So here
then
we
we,
create an empty node. We
yeah,
only allow them internally, I think. And
yeah.
we always
May,
like this one we create an empty node, we fill it up. But in remove, we also delete nodes as soon as they become less than half full, or as soon as we
yeah,
can.
yeah,
And so I don't think you can ever actually have an empty node. Um,
yeah. Maybe it's just safer though, like lower bar for correctness, we go back to the way you were calculating it rather than going on last absolute index. Then we don't have to even
Actually, yeah, I think you're
worry
right
about
that
it.
we do allow an empty node if you remove down to 0 items. We won't actually delete the last node because we allow
Yeah,
the last node to be less than half full.
yeah.
Um, so let's then, so this is correct for the return 0, and if it's 1, well, if the array node count is 1, then this will also be right though. Or will it?
It wouldn't be if there's one node and it's empty, we'll return that there's something when there's nothing. We'll return one because so if,
Why?
for example, if there's one node, so node count
So we'll get
equals,
what happens is we'll get an underflow here.
yeah,
It's not that we'll return really wrong. We'll fail because we'll get an underflow because we do -1 here. But
yeah,
we'll do 0 -1 on this line.
yeah, yeah.
So we should just do this ourselves. Is really what the answer is, and not do the
That's
-1. Then it's right.
that's what I was thinking. Yeah, for not do the plus one, so we can, and then we don't even need the branch here. Oh, we do still need that branch for
We
node
do.
count is zero. Yeah.
Um,
We could cache the last node so that the
yeah, I was
it,
going to do that.
yeah,
And this is, I'm pretty sure, still right. This just does. That, that's gonna give us that's gonna give us an underflow actually. Do array.counts, which is gonna be 0 -1.
yeah.
let's just stop using abstractions and like use the right thing. Actually, we used last here as well, so maybe we should need to fix that.
Yeah, it's interesting
Um,
because you see what we last is also there's the underflow because last assumes that there can be
yeah,
no empty nodes.
maybe last is just a bad thing in general. Oh no,
It then has to be optional. Uh,
the relative index maybe, um, or the return value. Yeah,
yeah.
making this API safe is kind of tricky. Um,
Perhaps we should say there can be no empty nodes ever. Like that, we want to make that strict because then
yeah.
we'll have a low bar for correctness. We won't rely on it, but we should still enforce it. It's still a good idea in the implementation that we.
I guess just make it delete the last node if it becomes totally empty. I think that's actually pretty trivial to implement, and that
Yeah,
would make this code a lot safer,
yeah,
or a lot easier to get right.
yeah.
So should I just go back to using last absolute index then? Yeah, I guess so.
I think we shouldn't rely on it here. I think so. I think we should enforce it to make stuff a strict. Like we want the strictness bar to be very high, but we want what we depend on to be very low. Those remember that idea again. So so
Yeah.
rather count, we don't want it to depend on that. Count, we want to be safe if the last node is empty. So in other words, externally, we assume nothing, that we assume that a node could be there, but it's empty. But internally, we're going to prevent that.
Okay. It seems like if we're trying to prevent it, we should test it then by letting
We,
the last node be empty.
yeah, we should test it. But what I just mean is like wherever we depend on this, the less we depend on something, the safer we are. Then we've got a lower bar for correctness.
No, I'm not seeing it that way in this case. The less we depend on something, the less it's tested. Um,
Okay, okay. Oh,
and
that we
what
can
we want to do
we
is just get it
can
right when it happens.
yeah. Then
That's the end goal.
so we should have a very high bar for what we assert on. But you see here if we just depend on it, we need to assert it as well. Then it's fine.
Hmm.
But I think we're on the same page. We do want the implementation very strict, no empty nodes, and then in count we must just assert that that's the case. If
Okay,
if
that's
if
cool
we
then. Yeah,
if we
as long
if
as
we
we just
de
assert that there's no empty nodes. Yeah.
exactly if we depend on it, we must assert it. Otherwise, we don't depend on it, then we don't have to assert it.
I
Then
think we should
how
just depend on it and assert
and assert, yeah.
rather than doing
That's
yeah. Cool.
that's better. Like in
We are
another,
asserting it already by calling in this function by doing the -1
yeah,
and in last. That's like
yeah,
what all our code assumes right now. I think it's better to just go with that.
yeah.
Let's fix this one, then we'll go fix it to make and actually do that when we remove down to 0.
Cool.
Um,
Just as a little like sidetrack, another example where we do that is we in our in our storage layer. So we sometimes like SQLite, for example, for correctness, they will depend on properties of the hardware, and they will try to test the hardware to see if they can depend on it. So, for example, to get some atomic rights at points, they will, if I understand correctly, they will see if they can depend on whether a disk sector can be atomically written or not. So in SQLite,
hmm,
often they do assume that. They assume that you can write a disk sector atomically. So the principle that I was just thinking of is that it would be safer to make less assumptions because that way you've got a lower bar for correctness. So when it comes to optimization, you can then say, okay, well, we're going to optimize assuming that the right will be atomic. That would be fine to do. But for correctness, it would be better to go the other direction and make less assumptions on the hardware, because that way you're always right. The less you assume, the less you depend on it.
Yeah,
Yeah. And then,
that makes sense for sure. I think in
and
this case,
we also want to
since we're
surf.
testing it exhaustively, then
Yeah.
I think what we
Yeah.
test is then what's the easiest to get correct. And so if we just test that this case is covered, then we're fine.
Yeah.
Um,
Yeah. No, I agree with you completely. Like we want to test it, and it's also better, like in our implementation, that we also even assert it, so we surface any bugs sooner, fail fast.
yeah,
Uh, I was
and
just
I
meaning
think in this case,
in general,
it's
like the principle outside, wherever we
yeah.
write
I'm
code, we
definitely
want
looking at
to.
the principle in general.
Yeah,
I just think
yeah,
it doesn't really apply here in this case. 'Cause in this case, we just want to make the code more rigid and make our asserts tighter and cover it with testing.
that's it. Yeah,
Um,
100%.
cool. So here we can use last node then. Do you want to use last absolute index or just leave it like this? This is already right, actually, I think. Oh, I need to pass in last here.
Yeah,
But other than that, I think it's right. It actually does handle the zero. Well, last doesn't handle an empty node properly
yeah.
currently because it subtracts one from the index, but
Mm.
that's
W-
fine.
We can
We
always
can also just use this.
we can
Um,
document that.
well, it should never be possible now.
Yeah, but like for
Well, here we
example,
can also
our
do this. We can just also do add some asserts here. Just assert
yeah,
um, array dot node dot counts um, 0 is greater than 0. I think that's all it is. Um, we can have empty nodes anywhere.
yeah. We could make it even stronger by just putting last in there.
Does that really make it stronger?
Or we could bind the two together. Um,
We actually are. We're gonna if we never make it to that sort of last is empty
yeah,
because we'll get an underflow here.
okay. So then it's better to put the assert first so that we get a nice crash.
I think.
Yeah, cool.
Oops. Now I think it's time to go fix. This
Maybe
seems fine. We can also just use last absolute index though, and then add one. But maybe that's
I like the way we're doing it more because otherwise, although it's still internal, if we use last absolute index, we're starting to assume that there can't be an empty node. But then
we
we
are
still
assuming that we're asserting that in fact.
we're setting
Um,
that, so then it's fine. But I like how we're doing it now. It's good. Maybe let's just call it last node, that variable. Then we're using the same as what we do in. I think there's one other helper we call it last node, last underscore.
all right.
Yeah,
And here we need to go and remove it if it's empty.
yeah,
If oh, you know what? We've now got an underflow here if it's empty.
yeah, ready.
So we actually need to fix this.
Yeah,
We should just compare B. We just should compare array that counts B directly. Or hmm. No, this is actually no under. Well, it is an underflow here, but we need to compare this to the node count directly. Array dot node count. And then we're going to say if counts So let's do it like this actually. We can actually leave it like that, but we need to first remove it if it's empty.
Yeah.
So we're going to say, we go back even further, return there, okay. But here we can do if array.counts b equals 0, then we can assert that it's the last node. Assert b equals array node count minus 1, and we're
Nice.
going to remove the node.
Yeah.
Because then we make this can stay the same then, and we also double check it here that if a node is empty, it has to be the last node.
Yeah.
So that will give us even more safety.
Nice.
And here we also need to decrement node count and then remove the node. So node pool dot release yes. Can we have this like right here somewhere? Yeah. Array to nodes node. Well, do we want to like just call it to this function? I think this one. Constant node. We could really just call this, and it will do some 0 length copies, which won't do anything,
Yeah.
and then set this up to 0 properly. So let's just call this
That's
move
better.
empty node at 0.
Yeah.
Yeah.
Then we use the same code path there. Then it's much better.
Indeed. Yeah.
Yeah.
Or you want to say B or 0? I guess hard coding it's probably fine.
B
B is
B
equal to 0.
B is better. Then we should uh, yeah, equals,
B is equal to 0.
because you see it could be the last node, but there might be nodes
Oh.
before it.
Oh. Yeah. I was stupid. Why should it be 0?
But
Yeah.
no, it's easy to make. I was thinking that too just now. So if we had put 0 there, it would be fine. But then we just need an assertion to bind the two together and to assert that B is
Yeah.
0.
It actually.
Um,
Yeah. It won't always be 0 though, because B
I know, yeah.
would be the last and there might be more before it. Yeah.
Yeah,
Anyhow.
I'm just saying if it was possible that it is always 0 and we plug in the 0 literally,
Yeah. Yeah.
then we have to do the step where you then jump from B to 0 and assert that they're bound. Um, then
Yep. I
yeah,
think this is right now though, right?
that, yeah, that's
They
nice.
need a comment here, I guess. So they don't. That's sufficient as a comment.
Maybe we should add a comment just also to highlight that the last node may be empty, but that doesn't mean that there aren't other nodes.
Um, sure.
How we could say,
There.
however, if the last node is empty, that doesn't necessarily mean that there aren't other non-empty nodes. Or
Let's see.
perfect.
How's that?
Yeah, that's nice.
Cool. I think that's good then. Nice. Now we've got our count function. We can use that in here. We can here just kind of expect equal reference items at length and count at the beginning and at the end. Equal context reference items at length, then array.count, and
Nice.
then same thing at the end. We'll also, I mean, you should expect that both of them are 0 at the end, actually, I think.
Well, we're
We never
not.
actually removed them from.
No, they should be the same,
Um,
beginning and end. They should be exactly
yeah,
the same.
we don't remove stuff, so we can do it a separate expect if there's 0 maybe sometime,
Yeah.
but yeah.
After that'll be in remove all.
Yeah. For some reason, I thought we were removing stuff here, but we totally aren't. We're just
Yeah.
checking consistency.
Yeah.
Do we really need this at both the beginning and the end then?
It's
Because I think we don't really.
it's not a bad idea because maybe by some bizarre bug the read path mutates stuff or whatever. So just check it
Sure.
before and at the end. Uh,
Yeah, it doesn't hurt.
no.
Um,
The
actually,
other
will this
thing,
even compile it right now? This returns like a U32, doesn't it? Oh, this
yeah,
also doesn't needs like a context.
yeah,
Context. This is gonna give us a U32, and this is a U size, so we need to like int cast this one.
yeah. Isaac, what do you think? Shall we maybe just check our implementation as well of segmented array, just to look over wherever we remove or wherever we mutate nodes or wherever we use last dot node, that we're getting our assumptions correct with like I think there might be maybe a
Sure.
place where we still use last node even though the array is empty.
Cursor for absolute index uses last node. Okay, where do we use this? Split node at full. At this point, can it be empty at this point?
So split node assumes that there is at least one node. So
Yeah,
we could even
but it
add
could
in
be empty because it could be empty actually. Yeah, I think we should just get rid of last and have like a last node function, or just like stop using last anywhere. Because if the problem is not with the node part, the part which is what we always use,
mm,
the relative index is what causes the underflow. We just want like a last node function. I feel like, or just this
the
is
challenge.
public.
The challenge is that the last node might not even exist, and we're returning an index for it, but it isn't there.
Um, yeah, that's true as well. Yeah, 'cause there could be no nodes in the array.
Yeah, that's the thing.
I think we should just stop using this internally. Is the real
Yeah,
thing.
yeah.
So you're right. I just found another bug. Like what we just saw here.
Yeah,
Where was it?
I
Doing
saw it.
cursor for absolute index.
Yeah, that's
Because here we use last absolute index, which use,
and the array might be empty.
and this one we use in split node to full, which, as you can see, it could clearly be empty if we've just started off.
Yeah.
Um, and so, yeah, what's the fix here? Cursor for absolute index. This should just return as 0, right? If it's empty. The absolute
It's
index it's allowed to be one past the end. That's the thing. Um, this should just return as 0 if it is empty.
I
If we just
think
delete it, so maybe it's just the assert has the bug. Maybe this function implementation is fine. Yeah, because it will just exit this loop right away because this won't be true. And then we're gonna get relative index. It's gonna be absolute index, which would be 0 minus array first absolute index node, which will give you 0 again. And then, so this is all fine except for this one assert. So we just need to fix this little assert here. Actually, this is
well,
also gonna get tripped in other cases because we also, to insert at the end of the array, like past the end, we do pass an out of bounds absolute index essentially. This
yeah.
assert's also just wrong. Um,
I think that we should try and see it. We, it almost feels like we don't even want to have a if the array is empty, then an absolute index of 0 shouldn't, in some cases, we shouldn't even be here.
No, I think it makes sense to be here. We have to be here. Otherwise, how do you insert to an empty array? Or
Yeah,
how do you insert to the end of an array? You need to pass like the index 1 greater than what your current maximum is.
yeah, yeah. But for some cases, then we shouldn't be here.
Right? Well, what case?
If we're removing, and there's nothing at all in the array.
Yeah. So
But
for removing, we should have this assert here, but for insertion, we can't.
that's the thing.
Um,
Yeah. I'm with you that we do sometimes want to have a cursor that's positioned at the insert location at the end of the array. I'm just kind of wondering, that's why I ask.
so maybe we should just move this assert outside of this function to the remove function and not
Yeah,
call it here.
yeah,
I think it already works properly. The remove, we can call this assert. That's the only other place we use it. We only use it in these 3 places. Twice in insert and then once in remove.
yeah. Shall we, like with all this in mind, maybe it might not be bad to just step through insert element and remove element and just go top to bottom and just review it.
Okay. Part of me says that getting the test done will catch all the bugs. And we
Yeah,
might want to just do that. But I guess stepping through wouldn't hurt.
yeah.
I'm just trying to figure out what's the most efficient way to catch all the bugs. If we'll be faster catching them through finishing up the test case and just running that and then debugging whatever comes up, or
Yeah.
stepping through.
It doesn't have to be faster, so whatever gives us the most assurance. So I would say,
Okay.
given that we've realized that our assumptions weren't like when we were coding this, we didn't have a clear like model around some of these cases, then I think we need to review it, and also hope that the tests help us, but we shouldn't depend on the tests. Like we should be pretty um, get our understanding up. And the time we don't have to choose. We just do both. We'll make great
Yep.
tests
Sure.
and just go through this again. Yeah. And I think maybe we'll solve it also like that last node interface. How are we feeling like about if it's the right thing to even have?
I think we kind of need it for iteration.
Yeah.
The reason we added it originally was for a segmented array, so you could iterate backwards and know where to start at for that if you want to iterate like the whole array.
Yeah. Yeah. Cool. Shall we just go step through it? Do you want
Yeah, I
to
kind of started already.
Yeah. Cool.
Um,
Maybe it's a time for a break, and then after the break we can come back.
sure. Sounds good to me.
Cool.
See you back in 5 minutes or so.
Yeah. Yeah. Awesome. Got you now.
Cool.
Hey, Isaac, we back? Hey, everybody.
All right, cool. So, shall we step through everything then? I guess we
Yeah,
kind of just started doing that. So, starting with insert element, um, we're going to go into here. We should also document that absolute index is allowed to be one past the end. I think that's kind of what we have to do.
yeah,
Um,
that's great.
and of the array. Or we say is the location the new element will be inserted at. In the index will take and maybe bound past.
It may therefore be one past the end of the array.
Yeah, that's good.
Yeah. Yeah, that's space.
Split node of full takes an absolute index and a node pool. And here we've now adjusted this to not panic when we pass in an absolute index one past the end. In that case, we'll just hit this first case where we check if node plus, well, we should also check for when we're not the first node. We'll probably iterate here, then we'll check absolute index is greater than array first absolute index node plus one. This will probably be true. And we'll end up at the last node in the whole array. And so then node will be exactly one less than node count.
Shall we
Yeah,
step through this one if the array is empty?
yeah. In that case, you hit node plus one is greater than array.node count right away.
Yeah. And then we'll say 0 is less than the node count, which we'll assert, which will fail.
Yeah. Well, the array is completely empty when we won't have, no, we will have already incremented node count. We can't get there without incrementing node count. Because we'll have done this, node count equals 1, if array got node count was 0.
Okay, so then it actually means that our cursor function can have that assert back where we were saying less than
Can
equal
what?
to. Remember we updated cursor for absolute index. We dropped that
Yes,
precondition
we did.
assert. We could bring it back.
Yeah, we removed that assert. But that was correct what we did. That's
Yeah.
not related to this. That's something different. There's two separate things here. One is checking that the absolute index may be one past the end of the array length. And the
Yeah.
other thing is checking that we handle an empty node properly.
Okay.
Those are two
Okay.
disjoint things. And so that assert
Yeah.
needed to be removed because it didn't handle an empty node properly.
That's why.
Um,
Yeah. Okay. 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 So this assert on line 7 is fine then.
yep. Uh, you see the problem we have here? We assert the relative index is less than array that counts node, but before we declare relative index.
Nice. Good catch.
uh, This one might actually fail though, because I think this one we leave at 0. I think
Yeah,
we just need to make this less than or equal to. Yeah, we actually
yeah,
need to do this because
yeah.
um, we need to have a comment here. Because assertion may target um, um,
May insert at the end of a node.
it's the end of the array that's the problem.
But also at the end of, in
Otherwise, we
this
would just
case,
be on the
it's,
next node. No, because we wouldn't. We would end up. This is only the case of the end of the array. Actually,
okay.
we can do a little bit better here with the assert then, because I realized that. So if we are looking at the last node, if
Yeah,
node equals, um, I wanted to use the last function again here, but maybe we shouldn't. Um,
yeah.
I think we just need last
But
node function or something. Or maybe we should just do
it's
this
just,
everywhere. Every node count -1. Just be very explicit. That's probably the
yeah,
safest way to do this. Stop tracking things needlessly.
yeah.
Um,
Definitely,
if
especially for these because we mutating stuff and we our metadata is not all, there's times where it's changing. So
yeah.
the less helpers we're using, the safer.
So if it's equal to the n, then we need to assert with that. Otherwise, we can assert without the equals.
Yeah, awesome.
Or we must.
Yeah,
Is that good? I
yeah.
should fix because.
We can say we must use less than equal to when examining the last node. And then, Isaac, I'm thinking like at the top of this function, I know we've got the two cases. So one is absolute indexes is inserting at the end of the array. Uh, but I think we could have an assert here. We could say that the absolute index must be less than or equal to the last absolute index
Yeah,
plus
sure. We can do
one.
the same thing here.
Yeah,
Um, well, yeah, we can make. Well, let's be slightly less strict than what we can do in remove. So let's go there.
yeah,
Um, we Here's the assert we took away from this place.
yeah.
Absolute index for cursor. What's this one? So let's put this back real quick, because even though it's wrong, and then we can see how we
Just
can
as,
change it to make it okay. And so I think
yeah,
it's just, well, the first one was that it uses last here. Um,
yeah,
First we need to get rid of that, so it's going to be array.node count. Okay, that's the first fix. And then last absolute index, we also need to then just add 1 if we, well, then it's going to underflow though in the case of, well, really we kind of want like count for the node. I think we should just get rid of this abstraction too and copy this part and
yeah,
then not add 1.
yeah.
Um, okay, so we have like a constant last node here. And here we can like, oh man, I messed up my copy paste then, but it's array indexes last node plus array that counts class node, and then no -1 or +1 or anything.
Yeah.
And it's less than or equal to.
Yeah.
And we should add that
We
comment
can
up here again.
also add another assert and say that because we know the elements count max, so absolute index needs to be less than that.
Sure, yeah.
And that might be a good one to do first, because if we fail on that one, the next one will also fail. So it's a
Yep.
quicker way to see what went wrong, you know? We could also then now quickly go and check all our functions that accept an absolute index and always assert that the absolute index is less than element count max.
Okay, sure. Or just F then, really. Okay,
Yeah,
so D in it, insert elements. You want to do it like right away here?
yeah,
Um,
yeah. Cool.
feels kind of redundant to do it everywhere, but I'm sure maybe we will catch something.
Yeah,
Unless that's going to take an
I,
absolute index. You
I
just
know, I
make
know.
elements.
It does feel that way, but that's how these assertions work nicely, is when they don't assume anything about any other function.
Oh
They just
yeah.
do everything they can. Yeah.
Oh yeah, I've definitely seen it in action before. I'm not really debating it. It just
Yeah, yeah, yeah. I'm with you. Assertions always feel like you're just duplicating everything, you know?
yeah,
Uh, like when we were
they
doing those
really do
comp
catch
time
bugs.
asserts, yeah, in the table layout, you know, for remember that LSM table layout, and we did a whole separate bunch of assertions, kind of not assuming anything, but a lot of it was duplicate. Yeah.
Indeed. All right. So, oh, here's another one. We have more of these. Iterator probably takes an absolute index too. It does.
Yeah.
I think that's it now. Yep, we made it
There,
to the
there
end.
we at under iterator we actually copied another assertion. I think we said start node is less than array node count. I
That was
didn't.
already there.
Sorry, I saw the wrong line there. Cool.
Yeah, I pasted it in
That's
the
it.
middle, so keep it like right up with this one.
Good.
Um,
Good. Yeah,
so back to
there we kind of
um,
just missed a precondition that we could have asserted on.
okay. Um, anything else to do here?
If you like, if we're going to get rid of our last function completely, then we can just call it last instead of last node.
I'm not sure we can, because I think we use that in manifest level, like to start iteration if we're going downwards.
Okay. Okay. So we do want it.
Yeah. Or we use it for this assert at least.
Okay. And are we correct here, like that we assume we can just call last even though there's nothing?
Um, yeah, because this weird state where we can't call last is only an internal state to our functions. It's not part of the public API. Like once if you call remove, it might temporarily enter this invalid state where you can't call last. But once it's exited, then you're allowed to call last again, I think.
Okay. So we won't get an underflow if there's zero
Well,
nodes.
I think we will actually. I think you're right. But hmm, this is even this is the only place we call it, right? I mean, it's just for an assertion.
Yeah.
Yeah, it's just these. That's the only place we call it.
Okay.
Is there a better way to do this? What are we even doing here? kind of asserting that we went to the end.
Yeah.
I think this is just maybe not a worthwhile assertion to do for this complexity of having the last thing that might return null or whatever.
Yeah.
Um,
I like the assertion here. We can just, if this is the only place that calls last, we can just then call um, oh well we need a cursor here. Hey. Yeah.
yeah, we're comparing adjusted to the last cursor.
Mm. And can we fix up last so that it doesn't overflow? It doesn't underflow if there's nothing. Maybe it just returns absolute index 0, like
Then
node
like return
0
the wrong
relative.
thing though. It's supposed to return a valid cursor where you can, because the cursor is like always supposed to have an element, but
Yeah.
I don't know. Uh, maybe
Maybe we
this
can
function assumes that
say
we already, yeah. Does this
have.
function not like assume that we have something in the segmented array?
We could even then assert that here, you know.
Insert what?
Yeah, we could assert that we expect there's something in the array.
I think we actually don't though, because perfectly valid to query a manifest level that is empty.
Yeah. So I think maybe we like we've documented our absolute index in the API, and we've said absolute index may be one past the end for inserts. And a cursor is just another way of describing an absolute index. So maybe we then need to do the same for cursor, make them symmetrical and say cursor can
So
point
allow
to
them to be
node
one past
0.
the end.
Yeah, node 0 relative index 0 if it's empty.
Yeah, I think that's probably the way to go here. That's what we do for first, essentially.
Yeah.
Okay, so
Oh, and you know that assertions is only going to fire if there is something in the array. If next return, oh, this is actually at the end.
yeah,
If the loop doesn't break. Okay.
yeah. I'm pretty sure we need to just change this API slightly then. That's
Yeah.
what we do for first anyways. If it's empty, it returns one past the
Yeah.
end.
Yeah.
Um, and so we just need to say, um, if node count is 0, we also have an underflow. So
Yeah.
let's just say if, because I think we can't actually have an empty node. Yeah, so we just need this case, I think. If array.node count equals 0, return. We can just return first, actually, if we wanted to. That seems kind of weird.
Yeah.
Maybe it's not
I
weird.
was I was thinking the same thing, and then I also thought that seems less explicit. But I think if we add a new line after it, then it's okay. Like that. Yeah.
It does make sense though, because like if you have nothing, if your
Yeah.
array is empty, then last equals first.
Yeah.
Um,
It does. Yeah.
it's not totally weird.
No, it's good. Yeah, and what I was thinking too is checked arithmetic is so nice because it would have caught every single one of these bugs.
Yeah, yeah. I mean, we just from running our tests, we would have caught all these.
Yeah, yeah. But without checked arithmetic, we wouldn't have known what is going on. We would have been dealing with like 4 billion something elements, and yeah,
Oh yeah. Well, we would have suspected an underflow right away, but we wouldn't know where it was. Um,
yeah,
that'd be the
yeah,
problem.
yeah,
Like checked arithmetic also just like points you to exactly the arithmetic operation that causes the underflow, which is really
yeah,
nice.
yeah,
Like in C, it's often that you like find an underflow somewhere. Like you see like some massive power of two, and you're like, oh, I've got an underflow in my code, or like
yeah,
it's like something slightly less than 4 million or four
yeah,
billion. Um,
yeah.
but then you gotta like go find it, and that's a pain.
Yeah, or if you use like your I variable after a reverse while, it will have already underflowed and gone back around,
Oh
and
yeah, yeah.
won't be zero, it will be something else. Uh, uh, cool, this is nice. Then we can
Yeah.
rest easy, you
All
know?
right.
Um,
Mm-hmm. Yeah, first. That works, yeah. And then we also, and we don't allow, what we don't allow outside of this abstraction is for empty nodes to be present. Either there are no nodes or there's a node with at least something in it. And
yeah,
so this -1 is fine, even if there is a node. It's only the case where there's
yeah,
no nodes that we need to return this. So I think we're good
yeah.
now with last.
Okay, cool.
And,
There,
but using it
there's one.
internally is still, sorry?
Yeah, yeah. No, you continue.
Using it internally is still not okay always because we temporarily have empty nodes internally during inserts and removals.
Yeah,
Um, but they don't last very long because we get rid of them right away. Either we put something in them or we delete the node itself in case of
yeah,
removal.
yeah.
But for the public API, it's now safe. Um,
100%. Can you see the bug in absolute index for cursor now?
oh, I haven't even looked at that one yet. Um, nodes less than absolute array node count. Yes, we just don't handle uh, yeah, we don't handle having no
Uh,
nodes.
yeah.
Um,
There's two bugs also. Uh, there's another one. It's we actually okay. This is easy. The compiler will catch it. We're just using node, but it actually we should be using cursor.node, cursor.relative index.
yeah, yeah, true.
Yeah,
And so here, absolutely for cursor, we say if cursor.node, or if, so when we say like if array, if the node count is 0, then like assert
yeah,
that cursor equals cursor.node equals 0,
yeah,
0 and relative index, and then just return 0.
yeah.
How's that look?
Nice. Yeah, beautiful. That's great. Then otherwise it's going to be less than the node count. Um, we still have a problem because we do allow the cursor to be one past the end. So our relative index is wrong for if the node
Right.
is the
Okay.
last node.
So this should be then less than or equal to. Is that right?
Yeah, yeah, but we can tighten it up like we did previously with the branch.
But yeah,
So
only for the last node. Yeah.
yeah,
Okay.
yeah,
So let's copy. Can we just copy that from here? I think we can.
yeah.
Um,
We could also make it a one-liner if expression within the assert.
hmm?
Can we make it a one-liner if expression?
Um, it'd probably be kind of long. I can try it though if you like. Um,
Uh,
it'd be like if node equals last node. It's gonna get really long. Yeah. We just need to copy
yeah,
this thing then.
cool.
I think I'm gonna ditch that. I think it's more
Yeah,
readable like this anyway.
yeah.
Um, and in release fast, which we're considering enabling for this one. Um, apparently,
Yeah,
this should be fine.
we can even maybe drop that comment because we were chatting yesterday that it isn't really. I mean, we can profile it, but my guess is it's not going to be a bottleneck because
Oops.
This is
Sure.
only after compaction, and we're putting in big nodes, so that CPU work for
Yeah,
the
well,
node
this
is much
one,
more.
we use this one in the query path too. This is part of the queries.
Oh, okay, okay. So then, sorry, we should bring that comment back. Yeah.
Cool.
Shall we do that C can be
That's what I
capital, and
thought.
we can, yeah,
Hmm?
we can, that to do, we can just sentence case it, capital C and full stop.
Yeah, yeah. Sure. Yeah, period, I guess.
Yeah, cool. Relative index. If you like this comment, we could just say insertion may target the index one past the end of the array, period.
Okay.
Then it's just a bit shorter and in that other place as well.
All right.
Cool. What do you think now? Are you happy?
I'm pretty happy with this one. Yeah,
Okay.
that seems all good to me. I think this one we also pretty much had finished. Is there anything else
Yeah.
we need to do here? I think not.
We just
Um,
got one more tiny compile error in absolute index. We needed to we need to define last node, and we need to use cursor
oh,
node and cursor relative
yeah.
index again. Yeah.
Oh, it's cursor.relative index. Yeah.
Yeah. And also cursor dot node.
Here, yeah.
And since we don't use last node again, let's just do node count -1,
Yeah.
inline it. And there's just a cursor at the beginning there, yeah. And then finally, at the end, we do relative index in our return line. Right at the end of our return line, we just need to add in the cursor prefix.
All right. I think we've got it now. I hope.
Yeah, I'm glad because now we've got really nice assertions. Maybe if we had only tested it, we would have fixed the bugs, but we wouldn't have beefed up the like our mental model, you know?
Yeah, perhaps. We definitely have like more lines of assertions than we have code in this function now. We got
Yeah. You think this is up there now for first place on the TigerBeetle's
in first
greatest
place.
function?
We'll see. I don't know if I can beat
Yeah.
that you're at those BR assertions though.
Yeah. Yeah. Remember FFS, that one that we had? It was
Oh
like
yeah, that was a pretty good ratio.
100 lines or 70 lines of assertions and comments and one line of code. That was
Yeah.
it. Yeah, nice. First absolute index. Can that fail if the array is empty?
Don't think so. That's just yeah, as long as the node's in bounds, which it will be.
It can fail though if the array is empty, then node is 0, then the assertion will fail.
In that case, we return 0 though.
Of course. Okay. So we won't get there. Nice.
I think you just have to provide a valid node to this function as part of its contract, I believe. And it does assert that, right? Yeah.
Okay. And these
I
are
think that
not
those are
public,
fine. I think
which
like
is
this because those are
great.
those are very clear. That you need to provide a valid node here, and so I'm happy with these abstractions. They're not too
Okay.
bad.
Okay. They're also internal only.
Yep, they're not public.
Yeah.
And maybe the code a lot more readable too. I find.
Yeah.
Um,
But you know that one we don't almost need it because that's just array indexes cursor node.
So we could just get rid of it too, yeah. You know, we added it because when we had that really long name, that's what happened.
Yeah.
We just get rid of it everywhere. That is actually
Yeah.
shorter than first absolute index. Um,
Yeah.
all right. I guess we're gonna get rid of it. So array dot. I think that did it.
Yeah.
Oh, I probably messed up the actual function declaration itself. Last. Absolutely. Yeah, this one's all weird now, because I've now replaced the function declaration with this indexes thing.
Yeah. Cool.
But
And then
worked,
maybe last is still worth having.
perhaps, yeah. So I think we just hit a case where we didn't want to use it. Where we use it
Okay.
currently. Last definitely saves us some writing. I think because we didn't want the -1, we didn't use it, is what happened.
Mm.
Yeah. I think we need to go through and audit the places where we call this. I think we should finish. Should we keep
Finish
going? Should we
stepping
do that
through.
now? Or finish the insert path?
Yeah, should we
Where are we at
keep
now? So
as you wish, whatever one you want to do.
let's keep going where we were at, so we don't
Yeah.
get like totally sidetracked. But I'm sure we'll get to that point where we mess that up again, then we can come back to it.
Yeah.
Um,
Okay.
the cursor for absolute index is where we're at. That's here. This is where we used to have that last absolute index call, but then we got rid of it because didn't want the -1. Um, we want to include, we want to allow it to be one past the end of the last node.
Yeah.
Um,
Oh,
we
I
we can
think
just
our
be using
last.
count here actually. In,
Okay.
Instead of doing this, we could just use count. Like, how's that sound?
That sounds good.
Cool. Because this one's actually like nice and safe too, I think. Yeah.
Yeah.
This handles node count being 0 properly. It handles, well, this is now maybe not good. I don't know. I think we kind of decided we
Yeah.
wouldn't do this. We just use
Yeah. Yeah.
the node count -1. And this is a array that counts 0 thing, a good thing to do? I think this isn't actually. Um, well, this is good for the public API, this assert, but if we use this internally, then we can't really do that because we have the case that we have an empty node that we're inserting into sometimes.
Yeah. Yeah. Yeah.
We just drop the assert or not use count? I'm not sure. It's kind of nice to use count internally though.
Yeah. I think we can drop the assert because we're safe. If there is a node, we are going to use the very last node. We're depending
Yeah.
that indexes are correct. Uh, so internally we have to just
Yeah.
watch out that if we call count,
So
we've got
count
the.
count will return you the right thing for sure.
Mm,
But based on indexes, of course. So
mm,
it's based on metadata.
yeah.
Well, there's no other way to do it really. Um,
Yeah. So wherever we call count internally, we just need to make sure our metadata is up to date.
yeah. But we already
I
need to
think,
be very careful whenever we make the metadata out of sync with the actual thing. We always do that right away to get back in sync.
yeah, if we keep
So
it like, if we do it immediately, then that
yeah, we
minimizes the
have to
risk.
do it immediately. Otherwise, it's going to be
Yeah,
very bug prone.
yeah,
Um,
yeah.
and so I think
This
this is
is,
now safe to use internally for most purposes. And I think that's going to
yeah,
clean up our code too, because it will replace last
yeah,
absolute index for doing most of the inserts.
yeah,
So we're back to absolute index for cursor. No, we're here. So now we don't need
yeah,
last node here anymore either. We can just kind of get rid of that and put it in the thing here.
yeah. Nice. We can also Yeah, group those preconditions.
We could assert and count that element count max is that what we return is less than the element count max if we wanted to. Um,
That's a good idea. Yeah,
yeah,
that's definitely good.
yeah, we're
Great
gonna
idea.
shadow. Oh, having a thing called count is gonna make our we're not gonna be able to use count as a variable name anymore because it'll shadow the declaration.
Yeah,
That's
yeah.
annoying. Um, ret.
Well,
How do you feel about ret?
let's call it result rather. And then I'm just joking now, Isaac, but we could also call it sum.
So, I feel like that's gonna be more confusing, even though it's like slightly more accurate. It's not really a sum
Yeah,
because you don't calculate it by summing up
no,
everything. I think
yeah.
result it count would be the right name, but
Results.
since yeah, I think this is fine. I think.
No, I was just making a little joke. It's fine.
I got you.
Yeah.
Wow, ZLS is getting, it sometimes shows you with all the references. That's kind of nice.
No,
I miss that from Sealing. Sealing tidy is pretty sweet for C code these days. Like you don't
yeah,
have to rely on it showing you all the references for things, so it makes like debugging or understanding code a lot easier. DLS isn't quite there yet because it only works within the same file you're in, and so you can't really trust it to show you all the references. Hey,
yeah.
Christoph, how's it going? Um,
Hey, hey, Christoph.
yeah. So now we've got that assert in there embedded into our count function, and we've got our asserts here. I think this one's done now, unless you see anything else we've messed up. Um,
Um, I was not sure about node less than node count if the array is empty.
this one, um, we can't call this with the array being empty. Well, actually, it's public right now, so maybe we are, but I think we should make this
Yeah.
private.
Hmm.
Yeah, we only call it in here currently, so we should just make it private and they just say you can't call it if the array is empty and assert the array is not empty up top to make it clear. Um, well, it's not. Well, yeah, we just need to assert that array.nodeCount is greater than 0. I
Do
think
we not
that's
use this
fine.
in manifest level?
No, we don't.
Okay, so it's not used anywhere
Use it
outside.
only in here and in remove once.
Okay.
So in the insert path, we know it can't be empty because, well, in the remove path, we know we have to have something to remove that's valid.
Yeah.
So we are asserting that. That's fine. And then on the insert path, we always have at least one node because if we have no nodes at the start of the insert, we create a new node. And
Yeah.
so this is also fine to use. And
Cool.
so I think that's the right thing to do for this function. Make it private
Yeah.
and insert this. This one we do
Definitely. Yeah.
use in, I think, in manifest level.
Hmm.
Yeah, we use that in manifest level. So we can't, this one needs to stay public and can't really do that assert. And it has to handle this case where node count is 0. This
Yeah.
one's fine. It's just an implementation detail for us. Um, yeah, back up to insert, I guess.
Yeah. Just on
Um,
that, like just to make a comment, I was wondering, where we've got last and first returning cursors, there we say that those cursors can be node zero, relative index zero if the array is empty. And because that's mirroring what we do for absolute index zero. Um,
yeah.
and absolute index for cursor also has that, but then cursor for absolute index doesn't. So maybe we should just document that, and because it's a bit different there. It's not symmetrical.
Yeah. Well, let's first look at would it be trivial to make it handle that properly? What would that require?
Okay.
That would just require checking. That would just require this check. We could do that too. We would just need to add this check at the beginning and return a zero cursor if it gets
Yeah,
hit.
yeah,
But we don't actually ever hit that in practice, so maybe we don't. Um,
yeah. Because then it's better just to assert that we don't and document it.
yeah.
Yeah,
Then we don't need the extra branch.
yeah, yeah.
Yeah. And so let's just document on the assert. Let's say like this function could trivially handle node count equals 0 um, by returning a 0
We could call it an empty cursor.
a 0 cursor, I think.
Okay.
Or, I don't know. It's
Zero, yeah, written out was nice. How you had it, a zero cursor.
0 cursor.
However,
However, we don't. This function is private, and we don't require this one.
yeah,
We don't use. This is an internal function, and we don't require this behavior. I think that's good.
yeah, that's great. Maybe we can just drop the trivially and say it could handle by returning a zero cursor.
Yeah. All right. I
Nice.
think we're actually back up to the insert path then.
Yeah,
Split derivative full. So this is where we left off. We saw this absolute index called and we jumped over there. So now um, we our cursor. We check if there's space inside this node. If so, we return the cursor right away. Otherwise, we assert that the count equals node capacity, so we don't go over. That still seems good. And we split the node, passing in cursor.node.
yeah. We've g- we've got a out of
So,
we've got a out of
oh
bounds
yeah?
access on counts because what could happen is we inserting but the array is empty. Okay, but we
No,
do
we
handle
can't.
that.
We do this.
Yeah, but maybe we should still um, just not even go into counts. If before we touch the counts metadata, we should have an assertion that the cursor node is less than the number of nodes, than the node count. Because
True.
then that's safe. Then we can just assert on it.
I'm happy with that.
Yeah. We could actually put that assertion grouped with where we access the counts metadata.
Not like on the checking in the return of this function. You want it
Yeah.
like this?
Yeah, that's fine. Yeah, like that. Because I thought that way it shows that, and maybe it's another pattern to check for. Wherever we access metadata with a node, we must assert that the node is less than the node count. Like check that the function scope does that.
That makes sense,
Just to,
yeah.
yeah,
Um, Part of me says that we should be using multi-array list here for these three fields, and then like just using the functions to get access to them. Then we would get balance checking there by default,
yeah.
essentially. I think we should maybe we want to actually try that. Um, I'm not sure if it gives you I'm not sure if it gives you like an exact capacity function yet though, because we want also a static allocation. That's why we've been using it like this.
Yeah.
Um, and it will also be
Um,
slightly more overhead because it uses like slices instead of array pointers then.
yeah.
Um,
We did talk about it, and then I think we thought that this would be better, and then we're also not depending on it if it changes or uh,
yeah, we can make our own abstraction that's similar though. That would like a
Yeah,
fixed multi-array list kind of thing that is a little bit more zero cost for our uses.
that's
Um,
a good idea. Yeah,
and we can get just trivially balance checking on all these accesses to the metadata. Um,
yeah,
that's like a not totally required refactor though. Like that could be maybe a good cleanup, but I'm not really sure if that's worth it or not. I don't know. Also something that someone can just do on their own without really being much
yeah,
discussion.
yeah.
Um, where were we? We were in
We
here.
were split node if full.
Yeah. Split node then we call with cursor.node. So we can go look at here. And we
That's
assert
pretty
the node
good.
is full too. Cool.
Mm.
This has to handle the node plus one being out of bounds. Well, not greater than node count max, but greater than node count. And here, look at that, we don't handle it.
Yeah,
That's gonna be less than or equal to,
yeah,
because we could be splitting the last node in the array,
yeah.
which means we have to add a node after that. And um,
Cool. I'm glad we've got node count max in there.
oh yeah, I'm very happy with that. This one was wrong, but I think these copies are still right. So what will happen if this is equal, then we'll copy nothing. Um, but that's fine because we don't need to copy anything if we're asserting the last. There's nothing to shift if we're inserting our node right at
Yeah,
the end. So that makes sense if
yeah.
we copy nothing in these. And then we just increment node count by one. Um,
Oh,
then node will be.
can I think we might get like what if node count is already at node count max and our nodes array
Oh
is
yeah, we could do
sized to
this.
node counts. Yeah, that's good. Where we take our slice on line 5 downstairs, array nodes, what would happen if we pass in the length of that array plus 1 as both as the arguments? Would that would be okay? So it's an out of bounds index, but they're the same. So it's a zero length slice, but it's still
Hmm.
out of bounds.
Node that would be out of bounds. We get a crash there.
Okay.
Um, yeah.
Because then we do have a those three would fail, I think, because it's possible that we already
Yeah.
at the last node,
So
but with nothing
here
to
we should then
copy.
maybe check if node equals node count before doing these three copies. So
Yeah,
if node less than, then we're safe. Good
yeah.
catch.
I was thinking over our break, if we spend like now, a few hours more, we get this really solid, um, then we've got great tests. Then whereas that's good. If maybe we're running this in production and it causes like a liveness outage, then fixing it would probably take as much time because we've got to jump into the code, push a release, do all of that. Um,
Yeah. It's definitely worth
yeah,
spending the time now to get this really solid. It's
yeah,
in some ways the backbone of our LSM tree.
yeah, yeah, exactly.
Read counts node equals 0. It's also going to give us an out of bounds, isn't it? Yep. Just me put this in here. How do you feel about that? We can't do the assert if node plus 1 is going to be out of bounds.
Yeah, yeah, good. Yeah, that's great. Nice style there. What if it's the last node? What if we've inserted the node at the end? Now array indexes is undefined.
Oh yeah, it is. I see what you mean. Yeah, if we add a new node to the end, we only handle insertion in the middle right now. Maybe we should just
Yeah,
always assign it and get rid of this assert. Or we can leave the assert there, that's still fine. But
we could calculate it always.
yeah, we could say this else. What we need to what we want is actually like the last index of the current of, of whatever is at node currently. Before we reassign
Yeah.
it.
Maybe we shouldn't do it like that though, because that's kind of how the bug arose, because we coupled it too much with the shifting. So maybe we should just, after assigning counts, just say, is the node index 0, then just set the index to 0. Otherwise, set it to the value of the previous index. Just a simple if-else branch there. So that it's totally independent of how we do the shifting.
Okay. Sorry, I just got lost in thinking about something.
Cool.
You're saying if node
Yeah.
equals node count.
No. So if node is 0, then set indexes to 0. Otherwise, just set it to the value of the previous node's indexes
So it doesn't make sense
plus
though.
plus its count.
Because we always it's it's not if node is 0, it's if node is node count. Or if node is the last node in the list.
So if it is the last node in the list, and we go and look at the previous node's last absolute index and make that our index, then we're correct.
Oh yeah, okay. Sure, that
I
makes
was
sense.
thinking, I was thinking of
Um,
something where we just unconditionally calculate it always without even thinking about the shifting stuff up top. Although it does
yeah,
happen to be, yeah. Oh,
it's a fine way to do it, yeah. Array.node count, array.node
and we,
count, or just if node equals 0.
yeah, and we could even make it a if
Well, node
expression
can't be equal to
assignment.
0 though, or maybe it can be. Can it be? No, it can't be. We always insert after the node we're looking at, and the 0 node can only be inserted right here. We can assert
Okay.
the node's not equal to 0 actually.
Oh, excellent.
Um,
Even better.
assert node is greater than 0. There can only be an element.
Nice.
And so here we can also, I kind of feel we should just add a second assert here. Um, like where we
Yeah.
actually use that fact.
Yep. Yep.
Maybe it's ridiculous. People might think this is ridiculous, but I think it's a good idea.
Oh, that's good.
Because then you like get the
It's
assertion failure right by the code that depends on it as well. Um,
yeah. No, no, I'm with you 100%.
we can have documents it for the API, but then we also then make sure we update the code if we ever break that.
Yeah.
Um,
Yeah. 100%,
cool.
Isaac. I'm really glad. That's good to put it there.
Array
I've
dot
learned I,
indexes.
I've learned this from you, like how we put asserts also close to where we rely on it and in the documentation up top. Yeah.
Oh yeah. Equals array dot indexes node minus one plus array dot counts node one. All right.
We could say that maybe the checked arithmetic now does give us the node greater than zero.
It would actually, yeah. So maybe it is fine to get rid of it.
Yeah.
Um,
That's what you
and
would
then
usually say.
yeah. Yeah.
I I learned
I
that from
usually
you as
don't I
well.
don't notice like the checked arithmetic things until I like see them written
Yeah,
out sometimes though.
yeah,
So I'm
yeah.
like, oh yeah, they'll just fail if it's zero, so it's fine.
Cool. Okay, and then we can maybe group it
I'm
up.
also like lining this up now.
Yeah, that's very nice.
This assertion is useless now, really. So four was kind of like showing why we didn't um, use copy. Now we just do it all always, which I think is totally fine. It's less bug prone. I'm just gonna get rid
Yeah,
of that. It's not a useful assertion. It's kind of asserts that this copy like worked properly, which isn't really a useful thing to assert, I don't think.
yeah.
Um,
Well, maybe like leave it there because it's not a bad. Just now we switch it from
it's
copy backwards to copy. Uh, well, okay,
and then
no,
we should like do it
yeah,
with the other ones too. I don't know.
yeah, okay, can drop it.
Cool. This is looking much better now.
Yeah,
I also like that we assign every field. We do something to every field here,
yeah,
and so it's yeah. We also got more asserts. We've got correct code, and we've got more consistent code. So
yeah,
yeah, cool. Now we've done this part of a split node. Now we need to go onwards. Half is node capacity divided by two. We do our complement assert there. Um, Pointer. That's valid index. I'm happy with that. New pointer is then no plus one, which also must be valid if we just inserted it. Then we copy backwards from new pointer or to new pointer, the first half of new pointer from the second half of pointer. Cool. And array counts node equals half. Array counts new node equals node capacity minus half. Yep, that's right. And array indexes new node equals. Oh, so we actually do set the indexes here as well.
yeah.
I guess we're just doing it here for safety.
Yeah.
Um, and if the compiler inlines this, which it may very well, because it's only called once, then it may get rid of these redundant assignments then.
Yeah.
Is it's actually a pretty removing dead stores is a pretty common optimization. If something is stored but never read, then
Yeah.
that's pretty easy to optimize out.
Yeah. Nice. What can I, should we take a look at that metadata there we've got in insert empty node at, just to check out
Yeah.
compares. So we've got node count, nodes, counts, and indexes. Node count, nodes, counts, indexes. And then up
And
top we
so
set,
here,
yeah,
node count and nodes don't need to be touched because those are the the count of number of nodes in the pointer, which are both right. And counts, we do update here. And indexes, we also update here.
Cool. I think the reason we update it twice also is because when we just split the node, we want the metadata to be correct. And then
Yep.
we move data between nodes, then we want it to be correct again.
Yep.
Uh,
And so it's always
yeah,
correct as soon as we made it incorrect, which is what we kind of need to do to keep this code like airtight. It's
yeah,
like whenever you invalidate metadata, update it right away before you do anything else. If we
yeah,
hold ourselves to that, then our functions will always work. We can
yeah,
like reliably call count, the count function, for example.
yeah. It's basically like
So
it's the same principle as time of check, time of use,
yeah,
but you just change it and say um, time of change, time of use. You, you, or time of change, time of update. Like when we change it and when we
yeah,
update the metadata, that must be the same. Because as soon as you
yeah. I think
allow
we
gaps,
yeah.
uh,
Really, what we must do is always just do it in the same function, and so there's no way to call a function that leaves your metadata in invalid state and not realize that. So you
yeah,
must always like see the invalidation and the update in the same function.
exactly.
Um,
Yeah,
that
yeah,
should be what we try and hold ourselves to in this code, I think.
yeah.
So I think
And
split node is good
even in the same function, it should be as close as possible to where it
for sure.
happens.
Yeah.
Yeah. Because we even
And so
remember you and
here,
I,
yeah,
we had that bug when we refactored storage. We had something where we write the message to disk and we calculated the message that must be written, but we calculated it like towards the top of the function. And when we actually wrote it out, it was much further below. And then we used the wrong variable. So we were writing the wrong data to disk. And if we had brought those two together, we would have been good. Uh,
yeah,
that's where I learned that.
cool.
Yeah.
And here we do it just back to back, because here is where we change the
Yeah.
amount of items in the two nodes. Then we update the counts right away and fix the indexes.
Yeah.
Um, so I'm happy with that. And here's the same thing essentially.
Yeah.
We need to do these copies first. Um,
Yeah.
these are actually not even invalidating anything. We because this is just copying. Well, they do invalidate stuff actually. Anyhow, um, yeah, this is the validation and the updating of the metadata right away.
Yeah.
So I think we're good here for sure. We'll need to make sure we do the same thing in the remove path, and then we
Yeah.
just do cursor again, which we've already looked at, and I'm pretty sure it's right. Um, that's a
Yeah.
misspelled word. Hold up. Optim. There we go.
Cool. We could also, where we say much more error prone, we could just say, but that would be error prone or more error prone.
Sure.
Cool. So we basically take the index, get a cursor out of it. Then we check, um, is the node for that cursor, does it have some space? If it has some space, cool, we don't need to split. Uh,
Yep.
and we've asserted the bounds on our array access when we go into counts metadata, so that's good. Okay, now we decide we need to split the node, then we recalculate the cursor again for that index. Yeah, I think
Exactly.
that's
Yeah.
good. Yeah,
Cool. So back up to here then. So now we've done our split of full. And now we just assert that we have space in our node. So that's what we were trying to ensure. And then we are
yeah.
going to shift the data in our node to make space for the new thing we're inserting. Do we get the bounds right here?
Um, so this is the node we inserting, pointer is the node we inserting into, right?
Yes.
Okay,
And then relative index is the index to insert at. So I
yeah.
think we might actually have an out of bounds here if relative index is like the last index in the node. Can that happen? Well, no, it won't never be one past the end here, I don't think.
We can then
Yeah,
assert it.
this is fine as it is because what will happen? You can only get for the last node maybe. If you're inserting to the very end of the array, then you can't do this, I think. Because usually when you're inserting into a node, you'll either have the relative index will either point to a valid element, but it can't point to like an empty slot in the same node. It would instead point to the next index in the first index in the following node.
Yeah,
But for the
yeah,
very last node, that's not the case. We will actually, I think, let's go back and look at our cursor for absolute index function again to make sure we get this right, or to make sure satisfy ourselves about this.
yeah,
So yeah, here we've got we allow relative index to be equal to array.counts node.
yeah,
Um, so that's the case we need to handle here. So if relative index is equal to array.counts node, and we're still fine actually, because it's still going to be less than um, it'll still be less than node capacity. It'll still be less than count max, and so it'll be inbounds for this pointer slice or this pointer to arrays thing. So we're fine here actually. This will be inbounds. I'm pretty confident.
yeah. Maybe we can assert that then, just above copy backwards.
Well, it is asserted by just doing the index.
Yeah, okay. Uh, so we're saying what we're trying to, like with copy backwards, what we're doing is we're shifting the tail. Uh, and, but what if there isn't a tail to shift?
Then we're gonna get what's gonna happen is relative index will be equal to array counts cursor node, which means you have a
Yeah,
zero size slice here,
yeah,
and you'll also have a zero size slice here.
okay.
Because yeah, this will also be the same thing, but this won't be
But
out of bounds for the pointer. Really, this won't be an out of bounds index for this pointer to array, because we know that there is the array.counts is not full, and
yeah,
so we can assert here actually that cursor.relative index, um, just to make this more
yeah, that,
easy to read, that relative index is less than or equal to array.counts cursor.node. That's the same like guarantee as that we have um, in our other function. But then now we just kind of like duplicate it here so you can like then compare this to what's going on here and see that it's okay.
okay. Uh, shall we just double check the less than or equal to?
It's got to be less than or equal to because it could be equal to the count because we're in the last node. We could also copy that whole if statement if you like.
Yeah, yeah,
Like,
to tighten it
like
up.
we can copy this whole thing,
Yeah,
shall we?
yeah,
Okay. Now we need to do this. This needs to be cursor.node and array.node count and cursor.relative index and then cursor.node. All right.
cool. I was just thinking one more thing. Where we access the array counts metadata, we should just have an assertion before there that we check cursor.node is less than node count.
Sure. Yeah.
Just to be in case split node does something funky, you know?
Yeah. I'm happy with that assertion.
Yeah.
And this is all this I'm good through here so far. This is also fine. Um Using the counselor one is fine. And then this loop cursor.node plus one. this might be out of bounds for if we're looking at the last node.
Yeah, because there's nothing after it.
Yeah. So if cursor.node, well, it's gotta be no. This is actually out of bounds. I'm not remembering what Zig does here. So this is exactly the length of this slice. I think this is out of bounds. Yeah.
Yeah.
And so we say what if cursor.node is less than node. Well, it's not even that. It's if cursor.node plus 1 is less than node count. Then we got to do this.
Yeah, maybe we could write it differently and say if cursor node is less than array.node count minus 1. Because we usually use array
Okay.
node count minus 1
Yeah,
to
you're
indicate
right.
the last node.
Minus 1. We also
Yeah.
say like not equal to, or then assert. We also want to assert that if this is false, then it's equal exactly to the last node and not like more than it.
Yeah. Yeah.
Um,
We do already have that.
could do. I guess we do already have that, so maybe it's fine.
Yeah. Because upstairs on line 17, we've got that it's less than the
Yep.
node count.
Yep. I guess I'm happy with this like it is then.
Okay.
Yeah.
So
Cool.
if we at the very last node and we're inserting the very last element, then there'll be space in the node. So the count of the node plus 1 is fine. The relative index plus 1, I'm just worried that that might be out of bounds.
No, it's actually fine because look at this assertion combined with this assertion. That asserts that relative index is strictly less than node capacity.
Yeah, but what if we, so I'm just thinking of the intention of copy backwards. What we're trying to do there is copy everything after the element, move it to the right. So I think the bug comes in where we are already inserting the element at the last position in the last node. And then we're trying to shift everything after that to the right, but there is nothing after it. So we do get a zero length slice on line 12, but on line 11, where we do relative index plus 1,
Okay,
that will
yeah,
be
you're
out of
right.
bounds. Yeah.
If this is then equal to node capacity minus 1, the plus 1 will give us equal to node capacity, and then we're out of bounds.
Yeah.
Okay. So
So we
the
should
fix
do
for
that in
this
an
is just to
if.
put another if statement, I guess.
Yeah.
Um,
Yeah.
if cursor relative index is less than node capacity minus 1. We're not looking at the last element in the node.
Yeah.
And then we can assert that we're looking at, if this is false, then we can assert that we're looking at the last node, I think.
Yeah.
Else, oops. Assert cursor.node equals array.node count. I'm pretty sure that's the right assert we can do that, right? Yeah.
Yeah. So I'm just trying to understand to catch up if our relative index is
It's not the
So
last relative index in the node. That
yeah,
means that we have, there is stuff after our relative index
yeah,
we need to shift. Or
yeah,
well, we need to shift from our relative index to those, or to that.
yeah.
Um,
Otherwise, assert we at
and
the
then, if
last
that's
node.
not the case, then that means that a relative index is actually one past the current end of the entire array.
Yeah.
Um, I believe.
We saying otherwise
Because,
we expect to be on the last node.
well, what happens if like the index we want to insert at is exactly the last index of a node that's in the middle of the list, and the node's full. So what happened? I think we're gonna split the node. I think. Yeah, because we'll split the node and then we'll leave space. That's fine. And after, because you can never insert into a full node, so we've already got this assert that that we already know that relative index is going to be strictly less than node capacity.
Yeah,
That's fine. What we're checking here is if it's strictly less than node capacity minus one. Okay, yeah. I'm back being happy.
cool. I think we just got one bug here because it's actually the -1 shouldn't be there. Because I think what can
Really?
happen is we can be at a node in the middle of the array and we can be inserting to the last element in that node. That's valid. Okay,
Um,
now maybe I've got this
no.
wrong.
So, um, I'm pretty sure that that can't happen. By inserting the last to the last element in the array, do you mean that the node is full, and we're
Yeah,
then
it
want
then
to, yeah. But in that case, we would have split the node, right?
we would only split the node if it's full. So in
Well,
this,
yeah, that's what I'm saying. If you're inserting, if the node's completely full and you want to insert to the last element, if your absolute index gives you the last element of that node, or is the last element
yeah,
of that node, then you need to split the node before you can get to this point.
what
If
we
the node's
are
not full, if there's like one slot left, and your
left,
last
yeah,
index is then your index is then like this I guess the last element in the node, so the second to last slot in that node. That's kind of the edge case we're looking at now, I think. And in that case, I think it's fine. Relative index plus one is going to be one less than node capacity.
yeah, yeah.
Um,
There you're
and
right.
so there's no out of bounds.
Because what we're really saying, it's the same as line 12 below. We're saying if there's stuff after this, then we want to shift
Yep,
that.
exactly.
Okay. But I think then where the bug comes in is line 7 because
This is cert.
it's
Yeah,
yeah,
I think this is
it's
wrong.
possible. Uh, yeah. Isaac, I've got a call coming in. Shall we take a lunch break for like a
Sure.
45 lunch break?
Um, Sounds good to
What do you?
me. See you back at 45 then.
Yeah, awesome. It's been nice. Yeah.
Cool.
Hey, welcome back. Hi, Isaac.
Hey, screen share going again?
Yep,
All right.
cool. I'm watching the stream this side. Great. Can you hear me okay?
I can hear you. Can you hear me all fine?
Yeah. Oh, good. Thanks. Yeah, sorry I was
Cool.
a little late. Adrian was showing me we were working out some options for two-phase commit transfers,
Cool.
talking about that issue we've got in the repo. While we're thinking of making it more orthogonal, I've been thinking, can we make it even more orthogonal? And because at present what we do is when we do a two-phase transfer, it's like the feature is very good for if you've got your TigerBeetle system and now you need to move money to someone else, like some other payment system. It's a totally separate distributed system. So you have to move the money from your system to their system, and it must either go through or not. It can't end up halfway in between where you think they've got it and they think you've still got it.
Yeah, right.
So the two-phase commit protocol is very useful there because it just does all of that correctly for you, which is otherwise pretty tricky to get right. But the way we do it is we've got it that you reserve, like a credit card, you want to move $5, and then later on when it goes through, it moves $5 across. We assume the amount that's reserved and the amount that moves is the same. But sometimes, like some systems, what they want to do is they want to authorize $5 to move, and then later on they realize, oh, okay, these are actually going to be our fees. Now we only need to move 2 of the 5. And that's also fine to do. So I think, you never know with these things, but...
Yeah. It's definitely not my area of expertise, but it sounds like then you could we definitely have the data. If we just go back to transfer structs for commits, if we get rid of commit structs and just have transfers, then you could definitely specify a new amount there.
Exactly,
on a technical level, that would work fine.
We could do that.
Let's just try and find the right API that's the safest and most flexible.
Exactly. And then what I'm even wondering is if we want to allow multiple subcommits. So you can reserve $10 and then you can move $1, commit it, move another $1, commit it, move $3, commit it, and then let the balance time out and roll back, because that would be perfect for Rafiki.
Interesting. And then so it becomes less of a two-phase commit and more of just a feature that lets you reserve money to be transferred out by then any arbitrary transfer coming from an account. So do you have to specify that? Is there any linking between the reservation and then the transfers that use the reserved money?
Yeah.
Can you do a different transfer during that time? I assume that is also.
Yeah. So it'll work. The way it works is that you want to authorize for $10 to move. When that happens, TigerBeetle will immediately take the money that should move. It'll move it from the posted balance of the account that it's moving from, or at present we call that the accepted balance.
Yeah.
Some systems call it the posted balance. This is the actual balance that's posted, and then this is the balance that's pending. So what TigerBeetle will do is when you authorize $10, we will move $10 from the posted balance. We'll move it to the pending balance of the destination account. So we take it out of posted, put it into pending, and because we track pending and posted balances separately, in other areas we can then see, oh, okay, you're going to have this money, but it hasn't come in yet, so you can't act on it. Then we only work off posted, or So we move the $10, take it out of the source posted balance, and we put it into the target pending balance. Then that means that other authorizations that kick off concurrently, they can only take off the posted balance and no more. That's all correct.
Cool.
And then as the commits come in, they will reference the original authorization transfer. They'll just reference it by putting that transfer ID in the user data and setting a flag to say that they're intending to commit. And then what TigerBeetle would have to do in the state machine is it'll go and look up the transfer, the original authorization transfer, look it up, and it will see, okay, that was for $10. Then it will go and do a query for all the commits that referenced it, a range query, because now it's using secondary indexes. So we'll get 0 to n, we don't know how many, it can be unbounded. We'll get 100 now commits, and we will see that of the 100 commits, they all committed like some fraction of a cent, and that adds up to $9, and we've got $10 authorized, so we're still good. And then another one can come in for $2, and we'll say, okay, no, that can't happen because that would exceed what was authorized.
Cool.
So that's the only thing at present. If we get rid of the commit struct and make it into the transfer struct, then it means we have to use the user data. And then it means we need to use a range query in the state machine. At present, we only do primary key lookups on a hash map.
Right. So I guess would that be then just slightly slower, probably? Depends. I mean, ideally that would be just as fast. I guess that kind of depends on how we do the LSM implementation for the hash map.
Yeah.
And I guess we would probably then add a cache of transfers based on user data as well for this purpose, and then add like when you have like a two-phase commit window like kind of started, when funds are reserved, then you can just put that transfer in this hash map indexed by user data essentially until it times out.
That's a very good idea. That's brilliant.
So we only would need to put in the ones that can actually be referenced by user data in this way, but I think that wouldn't be a really big issue.
Yeah. Yeah, that's cool. So we can actually do like a special caching structure for it without relying on range queries.
And we don't even really need to store all of them there. Well, like it'd be fine if we don't need to make the negative lookup fast, because the normal case is that these user datas in the incoming fulfill or at the second phase of this two-phase thing, they will refer to an actual transfer that was committed that hasn't timed out. That'll be like the normal case.
Yeah.
And so doing a negative lookup on that doesn't need to be like what we optimized for.
Yeah.
It's just like to have a fast path for the ones that do refer to a valid transfer.
Yeah. Oh, that's cool. So we're gonna have a special, if we see that a transfer comes in, it's authorizing a two-phase transfer. It's like the beginning of it. It'll have a special flag. It'll have a flag set. It'll say that it's a pending transfer, because I'm thinking that should be the new name, like following the credit card terminology, we call it pending. And then when the commit comes in, we'll have the flag pending accepted and pending rejected.
Cool.
Or we call it pending _ accept pending reject.
Okay.
Because we still need some good names. And then,
that sounds good.
Yeah, then we'll go look it up in the hash table. The only issue there is that then we don't know how many, like what the timeout of transfers is, like how long we might have transfers in our pending hash map.
Right. And so, yeah. I think it's a solvable problem though.
Yeah. Yeah.
It doesn't seem like a total showstopper. I don't know. I mean, we
Yeah.
have some access to the time, and we could just like evict them when they, I guess when they time out. Yeah, what would we time them out based on? Like based on like protocol ticks or like actual real time, or how do we handle that currently?
So we still need to implement that using the LSM index. We're going to create an index on the timestamp plus the timeout, which will be a future time.
Okay.
And that'll automatically give us a priority queue going to disk.
So it sounds like we would already need to do a range query anyways. Also, if we kept the commit struct to handle this timeout case, then.
Yeah. So I think kind of because what we're thinking, we've got our consensus log just before we call the state machine execute, which is synchronous function, non-blocking, and it's atomic, that function, because that's a very nice way to think about it for linked events and things. So what we'll do is we'll see the incoming batch, we'll scan the transfers, and we'll see, oh, these are pending accept or pending reject. Then we'll go look at the user data for all of them, and we will do point lookups on our LSM tree for transfers that have that ID. And we'll load them up into our object cache. Because we'll pre-warm, remember we've got like our prefetch function, and we'll put that all into our hash map. And then we'll just have to size our hash map big enough. Yeah. So.
Yep, I think that works out.
Yeah, awesome. Because at present, what Rafiki do, because they need to authorize once and then commit multiple times, because they don't know the actual amounts until they've gone over the different networks. So what they're doing is they're creating these sub-accounts for every payment that happens. They create a new account. Then they move the money into it, set that debits may not exceed credits, and then as the commits happen, and then they have to manage the timeout in the application with clock sync issues and then they've moved it. So it's like a lot of work.
That sounds like it could be a lot simpler and also just more performant in general if that was just done inside TigerBeetle essentially.
Yeah.
So then there's a lot less overhead. They don't need to create all these redundant accounts and
yeah.
Makes the whole system simpler by like adding a little tiny bit of complexity in TigerBeetle.
Exactly. Because I've been thinking, like I've been inverting recently and thinking, should we just not do two-phase transfers at all, and only keep two balances in an account, debits, credits, But I think we want to make things as simple as possible, but no simpler. We don't want to oversimplify, because if we do that, that's
it's definitely a balance. Yeah.
So what I'm thinking is that TigerBeetle it's accounting books, plus accounting policy, plus it's at the intersection of distributed systems. It's not just theoretical accounting, it's actual like real world between financial systems. So it's at the intersection of those three. It's not just the account, but we give some primitives like debits may not exceed credits, because that helps to enforce some financial constraints, And because it's at the intersection of distributed systems, it means we also want to give developers the tools that makes it just easy to build payment stuff, because the database knows that we live in a distributed world. So an accountant doesn't have to worry about that when they sit in front of their paper ledger, but
right, the numbers aren't going to change in front of them.
Yeah. So that
it's the analogy of trying to edit a spreadsheet while the spreadsheet's numbers are changing or something.
Exactly. There we go. Yeah, that's great copy. So I think that's because I'm thinking, do we just want two numbers as the balance? But I think four numbers makes sense because of all of this. So
yeah,
I don't know if you think we're on the right track to provide the proper protocol.
That makes sense to me, that we should provide just our primitives to make it easy to use in a distributed asynchronous context.
Yeah.
I don't have the accounting experience though to say exactly how it will be used or to make any big calls there.
Yeah.
But yeah,
Yeah.
we're in a
Cool.
distributed perspective, and it definitely makes sense to have a kind of two-phase sync
Yeah.
as a way to basically make sure your two systems are in sync.
Yeah.
Um,
Yeah. Because if TigerBeetle doesn't do it, then the application layer, which could have been stateless, now it has to keep state, because it now has to track timeouts for when stuff expires. And then
Yeah.
if the application layer crashes, when they come back up, they've got to now query TigerBeetle and say, hey, give me all transfers that haven't timed out. But then TigerBeetle will say, well, I don't know about timeouts, because I don't know about this two-phase feature. And the application will be like, no, but I also need you to store the timeout for me, please. Otherwise, I must store it in some other system. And then, so after crash, now they've got to do like a bulk load to get their timeouts back into memory so it's...
Yeah, so I think what we'll see is that if we don't implement this in TigerBeetle, people will use the TigerBeetle in a much less efficient way, because they need to do like a lot more logic of their own on top of it. And so if the end effect of that will just be like reduced performance for everybody.
Exactly.
Like TigerBeetle won't be easy to use in a high performance way anymore.
Yeah. Yeah, exactly. That will definitely, and it will be like, it is possible to do it. Like the biggest trick is actually, like, these are all like the lots of engineering work, to do the timeouts, and it's like lots of heavy lifting of code. It's like a big pain to write all of this. But the one thing that's very tricky is when you authorize the $10, now the application layer has got one system that's going to try and do the rollback. After a timeout, it's going to now do another transfer to move the money back again. And then concurrent to that, another part of the application layer is going to try and make the transfer succeed and commit. And these might be different instances, or it's distributed systems. It's not running. It's definitely not running consensus at the application layer.
Right. Yeah. They're not going to do that.
And if they aren't running consensus, it means that one system is going to try to roll back concurrently to another system trying to roll forward and commit, and they're going to just do that using single journal entries. And then the problem is that one transaction is going to move the money and give it to the other party, and the other transaction is going to reverse the money, and what will happen is that money will be magically created, which will violate Newton's fourth law of accounting, is that money can neither be created nor destroyed, but merely moves from one account to another, So, and then the only way to solve that one at the application layer is if the application layer takes care. So if they're trying to roll forward, then the ID of the transfer they use to do that must be a hash of the original ID, a deterministic ID. So they derive the ID of the commit from the original authorizations ID. Then the system that tries to roll back does the same. So they make their transfer ID a hash of the original authorization ID. That way the transfer that will roll forward will have ID 456, and the transaction that rolls back will have also ID 456. Then TigerBeetle can just do an idempotency check on the ID, and it'll allow one or the other to succeed. Then that's safe.
Cool. Yeah.
But so we could write up a whole blog post on how to use TigerBeetle for two-phase transfers, and then tell people to go and do all of this.
Yeah.
And then we just do one-phase transfers. I don't know what you think.
Yeah. I mean, then it's kind of like the question of how much we want to do for people, and how much people and how like that will affect how people use TigerBeetle and what they use it for.
Yeah.
Like that would be one option, but then that makes TigerBeetle essentially like a lower level building block of their system
Yeah.
than what it could be if it supported two-phase transfers.
Yeah.
And so they've got just like more work to do on top of TigerBeetle to implement like sound logic essentially.
Yeah.
And we kind of just have to decide which layer we think TigerBeetle makes the most sense at, or like which layer of abstraction and featureness, or like just a little primitive you use to implement your larger system.
Yeah.
And so one way would be to just not support two-phase stuff at all and just force that to be implemented by the surrounding system. But I think that sounds more complex than implementing it in TigerBeetle, like this scenario you've just laid out. And also that means that you then have n implementations for the n people using TigerBeetle. And so like from a large, if you take a step back and look at like how TigerBeetle will be used, I think it makes the most sense to do it inside TigerBeetle.
Yeah.
Because that makes it easier for everyone using TigerBeetle, which makes TigerBeetle more attractive as a product, and it makes it more likely that people will just get this stuff right, which I think is just better in general.
Exactly.
We don't want software to be crappy and have bugs that destroys money or creates money.
Yeah, exactly. Yeah. That's
I don't want to use such software, and so yeah.
me neither. Yeah. Yeah. Yeah, no, I think the same. I think it fits because we want to make it easy for people to build these systems. Here's a financial accounting database, and it doesn't just do bookkeeping. It doesn't just do the accounting books, but also the policy, and it works in a distributed context.
It makes it easy to get this stuff right and not lose data, and just like do this stuff correctly. I think that's just like the golden standard of API design, is to make it hard to do the wrong thing, or to make doing the right thing the easiest thing as well. And so if we don't do this, people will use it wrong. That's a given. I'm gonna just say that. And so it will that also give like TigerBeetle some bad rap potentially, even though it's not our fault. So
exactly. That's the other thing, is that you've got to try and ensure the success, of people who use it. Like, you should help them to be successful. They get it right. All good points. And I think also the what seems to be the case is that it's the kind of feature where, like, systems not all their journal entries are going to be these, auth accept. They're going to do it like credit card systems would do it all the time, because that's how it works. But some systems are only going to need to do it now and then, like when they on-ramp, like when they move money into their system from another system, they'll on-ramp, or when they off-ramp to export. Again, like whenever you move between systems, that's where it's really useful. And it seems like all these systems do it, so it just makes sense that like it should be there as a feature, like convenient.
I think this is a feature that pretty much everyone using TigerBeetle in a non-trivial way will want, and so
Awesome, thanks, Isaac. Like, it really helped. I was also concerned, like, how do we make it work from an implementation perspective in the state machine? Because we've got our object cache, which can do only hash lookups. How do we? So I was thinking, in addition to our object cache, we're now going to have to do range queries in advance of running through the state machine. But actually,
I think we just have a separate cache.
Yeah. We can even put it all in the same object cache, because
we really can. Just a different way to hash those things.
Exactly. Yeah.
Cool.
Yeah, thanks. That's a huge help. So hopefully it's been interesting for everyone else also watching. Like, now, Isaac and I, we're talking about like accounting features.
Yep. You ready to get back in the code now? We still got some work to do on the segmented array for sure.
Awesome.
I think we left off having pretty much finished insert element. So do you want to go like look at remove element now?
I remember there was one bug that we were thinking of. Remember? I think line 8 downstairs there, cursor node equals array node count minus 1.
Yes. Right.
Yeah.
Thank you.
we
Yeah,
realized
this
that,
is wrong, isn't it?
yeah,
So this can happen if you're inserting, yeah. So the case where this happens is if you're looking at a node in the middle of the segmented array, and this node has got exactly one slot left when the insert starts. So
yeah,
that means we don't split the node, and so the node still has exactly one slot left when we get to this point.
yeah,
But in that case, we don't want to shift because then we would be shifting
out of
stuff
bounds.
past the end.
Yeah,
But we do want to just insert, and so we just need to leave this. There's no, we can't have it there.
yeah,
There's nothing else we can insert there that's useful either.
yeah. No. Okay, cool.
What if there's some other place we did this assert? I'm pretty sure. Can we like look to see if where's the other place? Okay, this is it. We're gonna allow nodes to be empty. Even if the last node becomes empty, there may be other non-empty nodes. That is right in that context. Okay.
Yeah.
Yeah. Otherwise, we just check it. Cool.
Yeah.
Now let's just get rid of this assert, and we're good. Cool.
This is a lot of fun today. You know, I'm really enjoying. Like, we're getting into all the. I'm loving this reviewing and asserting and the
Yeah.
the discussion also like on these primitives is like really cool. So I've made it
Like how to do this the right way.
Yeah.
Like how do we make this code not have bugs?
Yeah, yeah. I'm learning. Like we both. I think we're all. It's pretty nice for everybody. Like we're just learning things as we go.
Always learning.
Yeah.
Never stop. All
Yeah.
right.
Just to take us on another tangent as well, because that's my job. You know. But I was also reading this morning a really cool paper on they're analyzing PostgreSQL's query planner, how it does like relational queries on top of the indexes that it's got. Basically, it's got indexes and a lot of stuff. Now it has to plan, you know, which indexes should it do intersections on first to reduce the state space and get an optimal query plan. But it's pretty interesting what they find, like some of where things break down, and they're also talking about the zigzag join algorithm, which has got very nice, like robust qualities. But I was learning this morning, so I actually want to share it in our Slack. We can check it out for after LSM when we write our query, you know, planner. Then
yeah, well, I guess that's still LSM stuff, but it's not like the.
it's still
it's kind of related, but it's not exactly like the storage part.
Yeah.
Yeah. It's kind of like once we finish the storage part, then we move on to the query part.
Yeah.
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 Cool.
Isaac, are you okay just to carry on? I just have a quick call, just to I'll be a second and then I'm back.
Sure. Go for it. All right. So I think we're done with insert element now. So on to remove elements. These asserts are both good. Equal to node capacity. It's just asserts that we can't remove more than a whole node at once, and that's to simplify our batch API. We go into. You also assert the absolute index. It's another assert we can do here, I think. Assert the count. Like the absolute index plus count is actually has to be less than element count max. Make that tighter. Because otherwise you could like start your remove elements at the last element, but then try and go on for 5 more elements after that. Which of course wouldn't work. And here we go backwards in an attempt to reduce copies. which is better. It just means we copy a little bit less, but it's not like on par with what it could be if we made this implementation do everything at once instead of one by one. Hey, I just made this a bit better.
Nice.
Before we didn't have this plus count, and so it wasn't really testing what we wanted it to test.
Okay.
We wanted to test like the last element in our slices inbounds for this thing. Actually, I think we might need to do that in insert elements as well.
But before we do, insert element, we've got it too. Can do it, but there's actually something we need to fix with it. We need to say less than equal to element count max.
Are you sure?
Yeah.
Oh, yeah. Mm-hmm.
Yeah. It's because I think it's because it's like the law of index units and count units. It's like when you add a count to an index, it gets pointer casted into a count, and then you can use less than or equal to.
But I'm kind of like picturing now in my head like a language with type safety with different types for indexes and counts.
Yeah. It would be good actually.
I don't know. Would it be like? It'd be hard to get right, but it could be really good.
Yeah. That's a very good idea.
That seems like a higher level thing, but I don't know. Is that something that's feasible to do? I don't know.
I think we could do it ourselves, just using the type system. We would give it a different, like a special kind of integer type that can't coerce unless we cast it.
Yeah, it doesn't have really the. Well, you also wanted to like define stuff like index plus count equals count and stuff like that.
Yeah.
Well, is it though? It's actually an index. It's not an.
Yeah. So here also we need to do less than or equal to.
Yeah.
Because for example,
the example here.
Like, shall we say element count max is 1, so a segmented array can have at most one element. Count is currently 0. There's nothing in the array at present, and we're going to insert at index 0 one element. So it'll be 0 plus 1 is less than 1, which would fail.
Yeah. That's obviously wrong. And then for removal too, it's well, for removal, is it different? I'm not sure. Let's try it. So let's say element count max is like 5, and we're trying to remove, I don't know, 2 elements. So count is 2, and then we're trying to remove the last 2 elements in our thing. And so the last element's at index 4, and the second to last index is at index 3. And so 5 plus 2 is exactly, or 2. 3 plus 2 is 5, which is equal. Yeah, so this is good.
Yeah.
Nice catch.
Cool. Pleasure.
Cool.
And brilliant catch also to actually put the count in there. That's like crucial.
Thank you.
Yeah.
And then here we don't actually need to do that because now now we don't need the count.
Yeah. What we could do there is to make it clear that we don't make the mistake. We could say absolute index plus 1 is less than equal to element count max. But we don't have to. I mean, it might have just helped us out in the other places that we would have seen, we need to actually put the count in here.
Yeah. I think that's fine. Do we like this last absolute index thing? Do we even want to use this anymore?
Maybe we don't want to use last node. That helper.
Yeah. I think we don't want to probably. Do we even use this? Where do we use this now? An iterator. We use this in a remove element in an iterator. We also do the same assert exactly.
Yeah.
So actually we can't do this anymore. We have to come back and fix this, or we can just do it now. Is this?
Yeah.
Or, no, this is actually fine now, I think. This will give you node 0 if it's empty.
Yeah.
And then last absolute index of node 0. Well, node.count will be 1. Node.count could be 0 though. If it's empty.
Yeah. So it won't work.
Should we just get rid of it, or should we fix it?
Are there only 2 places where we use it?
Yeah, we use it a bit more in iterator start. Use it for just the descending thing. We check it fairly often here.
Okay.
It does make things more. We check it places here in descending, which does make things more readable, I think.
Yeah.
Absolute index. Or maybe, I mean, the alternative would be we're also doing node -1 here, which is, if it makes sense, it's correct, but it's still slightly scary. I feel like if we check a node greater than 0 here, then we do. I'm not going to do anything there. It's just indexes plus counts -1. But we can also get rid of the -1 and just do less than as well. Maybe that'd be cleaner. I think that would be cleaner. Why don't you just try this, I guess. Indexes plus array counts. And then we need to get rid of this equals here, and then I think it's all good.
What we want to do is get the index of the previous node. The last index of the previous node. Yeah. So that's previous node plus that. Yeah, that's right. And can we copy paste our absolute index, our last absolute index implementation, just like up above as a comment so we can compare?
Sure.
Thanks. So we're still passing node -1.
Yep.
And then instead of using less than or equal to -1, we're now comparing it to a count. Yeah, because we've taken an index, we've added a count, so that converts the index to a count type. And that's why when we compare an index against a count, we use less than.
Yep.
Great. Yeah, I think that's nicer like that.
Yeah, I feel like it doesn't read quite as well though.
What we could do is we could make it just a plain reverse loop and then do the condition inside the loop. But then it means we can do it inside the loop after we've decremented node. But then it's too late because then we can decrement node.
No. We can't do that.
Can't do it.
So
I think it's fine. I think it's fine.
Saying, is if. Yeah. So what this loop is really doing is saying, while we're not the first node, and while our absolute index is not in this node, it's in the next node, or we're really checking that it's not inside this node, where it could be. So maybe we could just look at the indexes of this node then, right? Like, why do we need to look at the next node?
That's how it works. What we're trying to do is find the node. So if this node, what we're saying is if the previous node's last index is greater than what we're looking for, then we know that what we're looking for is not in the current node. Therefore, decrement the node.
Yeah, what I'm saying is that this is equal to this expression right here, the indexes of the previous node plus the counts of the previous node is equal to this.
Oh, yeah.
So, yeah, that's even better, right?
Yeah, nice. Yeah.
Yeah. I'm happy with that now. Okay.
Wow, how did we get to... This is much better.
It's because of this abstraction. This abstraction misled us. As before we were using the first absolute index thing here too, I think. Yeah, and let's just check this one again too, I guess. Because here it makes sense too, because here we're doing node plus one, and node plus one. Here we're doing node and node now, and so that seems to be, yeah. So while node plus one is, well, if the next node is not past the end, if it's a valid node, if there is a next node, and our absolute index is greater than or equal to the first index of the next node, then go to the next node. That also makes total sense. Yeah.
And while our absolute index that we're looking for is I think there might be a bug there even.
In here?
Yeah, because what if, like, we're going in ascending direction? So what we're saying is if our absolute index is ahead of the next node index, then jump to the next index.
That's what we want to do there, right? This absolute index here is the one we want to start iterating at. And so we're saying if it's, and this is the first index, this will give you the first index of the next node. And so if the absolute index is equal to the first index of the next node or greater than the first index of the next node, then we want to increment our node. If that's not the case, then we're already on the right node. Right?
Okay, so if our index is before the next node's index, then we on the right node.
Yeah, then we break.
Okay.
Yeah. And then we assert that, yeah.
Have we got that assert further down as well? Same.
And we can add that here too, just to make it super abundantly clear. Well, we assert this here, yeah. That is the assert I wanted to add.
Yeah.
I'm happy with that code. And in our assert here, we actually would have caught our bug here. Or it wasn't a bug, it was just bad code.
Yeah.
Needlessly complex.
Yeah. Yeah. What we could do is, can we check up a little bit at the top where we get start node from? Okay, we do check that it's less than node count. So that's good. So we know it's in bounds. And after we ever increment node, we check it again. So that's also good. In our ascending branch, then what I'm thinking is we need to always check out against node count before we touch counts metadata.
Yeah. And here we know that's greater than 0. So I think we're good on that.
Yeah.
Count. Nice. Shall we get rid of this one too then and just delete last absolute index completely?
Yeah, definitely. It's paying dividends.
It really is, yeah.
Yeah.
It's the dangers of too much abstraction.
Yeah.
So this one I think we do want to add count, but we can get rid of the -1 again.
Yeah.
And actually, the reason we did this in the first place is because our variable name was too long. That's the only reason that we ended up doing this. And so that's also a lesson for us that we shouldn't make variable names that long in the future. We did realize that and change it eventually, but
yeah. There's like a happy medium.
Yeah, it's always a trade-off. Plus array that counts start node, and this is just going to be, instead of being less than or equal to, it's just going to be less than strictly. So that checks that. In this also, in this case, we shouldn't be doing start node +1, because this would be the same as the indexes of start node +1. The problem is though that you then go out of bounds if start node is the last node.
Yeah, exactly. And the less than alone is correct because we've taken an index, converted it into a count, and now we're comparing an index.
We had the -1, but now we don't have it anymore.
Yeah.
And it's also still under 100 columns, so everything is worked out pretty great.
High five.
There's one more place where we call this. Or there's two more actually. There's one more here actually. Oh, it's the same thing, isn't it?
It's,
no, that's a move element now.
This is pretty funny. Like today has kind of been naming things and off by ones, and we've spoken about caching as well. So we've done it's been a good day's work.
For sure, yeah. And we fixed a ton of bugs actually. It's kind of funny how many bugs we're fixing now without having finished the test cases. We just kind of came back to the code after like 2 days and then found all the bugs.
It's the threat of fuzz testing. Like we know we're about to run a fuzz test. Okay, well, let's go check everything. Like
well, let's just go fix the bugs first before we run the fuzz test.
Yeah. That's classic.
All right.
But it's really
cool.
coming nicely together.
So this assert is like the same assert we had here. So why do we have it twice?
I think because we're mirroring the ascending branch.
Probably. But we can assert it here too, right? That's a fun thing to do.
Yeah.
And why can't we assert? Oh yeah, I see why we can't assert this in the descending branch, because that's not going to be true necessarily.
Yeah.
Wait, this doesn't hold true for the ascending branch though. Oh, I realized I changed something. This was array.last.node, not start node.
Okay.
Asserting that it's inbound to the whole array. So we can just need to copy this but switch it to the last node.
Yeah.
Whoa. Unzig format, there we go. And then this can just be, well, I think we probably need to I can try and see if it fits.
I learned that from Larice. Like Larice, if you're watching, thanks so much for showing that it's nice not to introduce variables into the scope. Try and put stuff in line if you can. And obviously there's a balance, like when to do that, when not.
Yeah. Looks like it's too long though here. We've got 110 columns. I don't really want to wrap it.
Yeah.
Call it last node maybe. We ever use that anywhere else? We've probably gotten rid of almost every last call in here now too by this point. So we call it once in our test. Call it once here. We still need to replace this one though. And then once there. Yeah, we've almost gotten rid of all the last calls as well.
Nice. We're
peeling
going to
away
keep
the
that.
abstractions.
Yeah, that's great. Are we going to keep that just for manifest level to use?
Indeed, we need it for the public API, but I was just kind of realizing we kind of stopped calling it internally, which is I think it's good.
Much better, yeah. Isaac, for our iterator there, just before the switch, shall we add a new line so that the preconditions are all grouped?
Yeah,
Like
that's
that?
good.
Yeah.
We also need to fix this. This one still needs to be shorter, and so I guess we can just call it like const last node equals. Whoa. There we go.
Cool.
Now looks good. Okay. I think that's enough of this sidetrack. Now we can go back and fix the last one we had. We had one more of these. Last absolute index here. I think that's the last call. We now just have the function itself and this call of it. So I can maybe delete this and bring it up and we can look at it. And then we can get rid of it completely. Last absolute index. No, this is the same thing as we had before, yeah. So we can just grab the last node perhaps and then also use it here instead of it calling last. Okay. I just did this. I'm going to go back and copy it from iterator. And here we can just use last node.
I think we shouldn't. Maybe we shouldn't use last node there, just because then we've got maybe time, like could be a gap if we ever update anything, and the like for that check for B, I think it's better just to do array node count -1, like we do in the assert on line 20 as well.
Sure, that's fine with me.
Because up top we're kind of just doing it so that we don't wrap.
Indeed. And here we can just.
We could always just make it a multi-line assert. Yeah.
Here, instead of like introducing the variable.
Yeah.
I think it reads nicer like this.
Just wrap it.
I think it just reads better on one line. I don't know.
Okay. Yeah.
So,
okay, cool.
Yeah, I prefer it like this.
Yeah.
I also wouldn't really mind last node here and here. It is like constant. Yeah. I'm not really too worried about this changing.
Yeah.
But what if node count changes? I guess is the worry.
That's my. And it doesn't. I mean, we know that it isn't going to change here, but.
Yeah, it's you're right. It's safer like this because node count could change.
Yeah.
And so we could also just like scope the asserts if you want to like keep the variable from like just being available. So it would be a compiler if we tried to use it down here.
Yeah, that's great.
I guess I can try it on like wrapping the assert. I just think it's gonna look kind of bad. But that could be better than like letting this variable leak.
Yeah.
So that's how it looks. It's 110 like that, and then where do we wrap it? Like this here?
Yeah. Yeah.
Not enough, is it? That's 90. Is that okay?
Yeah. It actually lines up nicely with the previous.
Yeah, it's not bad. Other option would be to do it here. I think I prefer the other way though.
Yeah, the other way. And I like it that we don't even bring in that variable. That feels better.
Yeah. Should we do the same thing down below then?
Yep.
Here. Yeah, it's the same number of lines. Then we don't have a variable leaking around in our scope.
Yeah.
Otherwise, we actually only now create last node variables in very small scopes. So in count here, where you can see the whole function, and then last here.
Yeah.
So actually, we could just, here it is kind of nice, I guess. We can get rid of this one though if we wanted.
Yeah.
Might as well. I feel like we're already doing this everywhere else. So, whoa, more than I wanted to copy. There we go. Wait, way too long. This reads a bit worse though with the -1. I guess it's fine. Yeah, I'm not. I think that didn't really help anything, but
Yeah.
maybe it's
No,
better.
yeah, it's fine like this, I think.
Cool.
It's such a short function, it's not too tricky to understand.
Yeah. Should we do it here too, or is that overkill?
Let's see, like
I think it actually gets in under the line length. Oh man, I've like pasted it twice somehow. Did I copy too much? I think I copied too much. Okay. Yes.
Nice.
It's exactly
Okay.
100, so I think we're gonna just leave it like that then. Cool.
Perfect.
Okay, well we've gotten rid of everything last node related. No longer appears in
Awesome.
this file.
Awesome.
And we've now got, got another good assert here. There's no more last node for element, or last index for node, or last, well, it was first absolute index and last absolute index. They're both gone now too.
Yeah.
And we've also got, now I guess we can just keep on going through remove then. So cursor for absolute index. Okay, now we've asserted the node count is greater than 0, so that's good to keep in mind. And we also have to have a valid index here.
Yeah.
Here we've already looked at this one, really, but we
Yeah.
can just skim it again.
That while loop, I'm wondering, so we're saying if there is a next node, and if the index we're looking for is above or equal to that node's index, then let's go to that node.
Yeah.
Okay, that's good.
That parallels the while loop we looked at here in iterator. Exactly this loop, except starting at 0 instead of start node.
Okay. Yeah, cool.
Because we don't have a start node, sadly, here. We could actually start taking a start node if we wanted to, but I think it wouldn't really save that much. Maybe it would.
Instead
That'd
of
have
an
to be like
absolute
pinned to the API
index.
though.
Yeah.
Hmm?
You mean a start node instead of absolute index?
Well, we could take it. Well, what we do for iterator is we take a start node hint essentially.
Yeah.
We can skip some iteration if the caller knows the start node or knows a start node hint, which the caller stores. Like in level manifest here, store these root table nodes to. Those are the start node hints we pass into the iterator start function.
Yeah.
And so if we saw a performance bottleneck here, like in this, if this started showing up in our profiling as like a hotspot, then we could consider adding an optional API to pass in a start node to like jumpstart this loop and skip the first 100 iterations or whatever it ends up being.
And then our inserts will actually end up needing to take a start node.
Yeah, which they wouldn't be really aware of, and so I think, well, they still need to do like a lookup though to find the right spot to insert in the array. So they probably are aware of a start node. I think this is a pretty easy thing to factor in in the future though,
Yeah.
it really just look like an extra parameter here into the function above it, and then the logic doesn't change at all. We just really pass in the start node to this function and change this 0 to a start node function, and then do some
And then
extra
we-
asserts.
Asserts.
So I
yeah.
think, yeah, I think that's really easy to retrofit. So we shouldn't bother yet, and
No.
we should instead focus on getting the batching API done.
Yeah, I think so too.
It's gonna be tricky.
That's a good idea. Just gonna switch the SE quick.
Go for it.
So are we done on the remove path, or we still gonna?
No, not yet. We still need to. We've gone to here.
Yeah.
We just need to look through all this stuff. Yeah.
Okay.
Not done yet. So B
Yeah.
is cursor.node. B pointer is read.nodes B. Okay, so B is the last node. This seems like it's gonna be out of bounds.
Yeah, it's the same.
Right. Same thing we did up above, right?
Yeah.
Actually, it's less than that, then we can do that. Otherwise, it must be equal.
Yeah.
Actually, I think I like it better to do it like this. You can let me know what you think. Well, we've already asserted it's less than or equal to node count, haven't we? No, we haven't. I guess we could do that.
Yeah, I thought we should do that even before we go into array nodes using B, because we're starting to access the metadata, but we haven't checked cursor
Yeah.
for absolute index.
So we can here just like maybe assert. We do that like up here. Just assert
Yeah.
cursor.node.
Yep. And then we need to use
Then-
array dot node count in that assert, less than array dot node count.
Yeah. B is less than array.node count -1. Yeah,
So we
that
good.
seems okay.
Yeah.
I feel like we should use B+1 here, though, since we use B+1 in the actual thing. That's more okay.
Okay.
That's why we're doing this. If you
Yeah.
are okay. Oops.
Yeah.
Yeah, I totally lost my place now. I jumped to the next thing on my search, but it wasn't what I wanted to do. Anyhow, here we are again. +1. That just then mirrors this exactly, so you can see that this is what we're checking has to be inbounds.
Yeah. That's much nicer like that.
Array count B -=1. Then we copy. I'm sure this has the same problem we had before too.
Mm.
Now it's cursor relative index +1. So
It doesn't have the problem because we're shrinking here.
are you sure? If we're looking at if we can end up removing the last element in the node, in which case relative index is going to be the last index in the node, which means relative index +1 is going to be out of bounds.
Oh, of course. Okay.
So yeah.
Good. Oops. Okay.
But we've just shrunk it here.
Yeah.
Relative index, what's the maximum relative index could be, really? I still think it can be the last thing in the node, though, yeah.
Yeah.
And so, Yeah. Actually, we don't need to compare this to well, we can just compare this to node capacity, I think.
Yeah.
Is that what we do up above? I think that is. Let's
Yeah, let's go check.
we did this before. We did mode capacity -1. I'm gonna switch this to +1 to mirror the actual thing we're using.
Yeah.
Like I just did that on the other one there. So
Okay.
it matches up with this.
Nice.
And then we're gonna
Much-
do the same
much
assert
better.
here, I guess.
Yeah.
It's gonna be, this is all good then too. This now also matches up what we did up above, which seems right.
Yeah.
Yeah.
Cool. Yeah, that's nice. I think that looks right.
I'm just checking. I feel like it's kind of weird that we did this first, but I think it was just to make this code more symmetrical with what we do up above.
Exactly.
We reverse
yeah.
the order then.
Yeah.
Because here we update indexes, then counts, then we shift the data to cover up or just to overwrite what we just deleted.
Yeah.
And if there's no data to shift, then we just leave it. We could also like write like an undefined, or I don't know. What would you write here in this case? We could write like an undefined to the data we've just shifted out of, but maybe that's overkill.
Yeah, I think that's okay.
Now we're leaving.
Oh, now we're leaving?
We're leaving essentially we're leaving the same data at relative index +1 and relative index after this. We don't like overwrite the data if we shifted away from. Well, it's not at relative index. It's at array.counts.
Yeah.
B. We
What
kind of
we really
leave that
need-
data there.
I think what we need here, because we're using optional pointers, we should be doing a mem set to set those to null.
That's not related to this yet. That would be in the remove empty node thing. The here what we're doing is we're shifting the things we're storing in the segmented array, the T's, the table infos or the keys or whatever.
Yeah. We're shifting them to the left, but after we've shifted them to the left, the last slot that is now free.
Exactly.
That
so I
should
think we
be
should be doing
nulled
that to
out.
undefined.
Oh, but
For zero?
we use an optional pointer for nodes.
No, these aren't nodes though. These are elements.
Because this is within B pointer.
This is the
okay.
elements.
Sorry. Okay. Cool. It's the elements. Yeah.
I think just saying to undefined would be the best thing to do.
Yeah. Let's do that.
Just to show intent.
Yeah.
And also get some more safety. The B pointer.
I've got to jump. Shall we make it to do here? Because I've got to jump to catch up with Proddy for the client work.
Sure. To do. Or pick up here tomorrow.
Yeah, it's been fun. Tomorrow we'll finish the fuzzing. Yeah.
All right. See you tomorrow then. I won't keep you late for Proddy.
No, cool. Do you want to sign us off?
Oh yes. TigerBeetle sessions, Thursday, 27th of January, session 12. Signing off.
See you, everybody.